Right. Good morning, everyone. My name is Kima Boswa, and I am with the Oklahoma State University Solid Waste Management Extension Program. I want to welcome everybody, those in both those attending in person and virtually, to our first PFAS workshop for solid waste systems. Just so you know, this workshop is being organized by the Trihydro Corporation and the Oklahoma State University Solid Waste Extension Program. Just a little background about our extension program and where we got the funding for this workshop. Our program is operated under the Solid Waste Management Grant from the United States Department of Agriculture, USDA, to provide technical assistance to rural and tribal communities, as well as to communities with population less than 2,500. So technically, we provide workshops, trainings, and provide educational resources on solid waste management to those areas. We included this in the grant since 2020, and I have been so happy to work with Andrew from the Trihydro Corporation to put this together. But because of COVID, we're moving back and forth, and so happy that we're here today. So just a little housekeeping. Bathrooms are on this end. You go out for those in person, actually. You go out, you see that, and I will let Amy do the other housekeeping update. Amy?
Thank you, Kima. My name is Amy Blythe. I'm the event marketing manager here at Trihydro Corporation, and I am actually in Laramie, Wyoming. So welcome everybody to our hybrid event today, PFAS workshop for solid waste systems. Right now you'll see the agenda up on the screen. Just note that we had a slight change in timing. Our lunch now is going to be 11:30 to 12:30. With 2 presentations before and 2 presentations after, and then we're going to open it up for a roundtable discussion. So we're very happy to have everybody here, and thank you for joining us. Just a couple excuse me. This is Kima. Do you want to talk about this, and then I'll get into the GoToWebinar housekeeping element?
Oh, yeah. So just for everyone online, we have a master's program in environmental science, and you can get jobs from the environmental health and safety. So that is something you might want to check out, and you can check out the website and for more information and things on that program.
Thank you, Kima. All right, so just remember that we are recording this session today, and it will be available tomorrow. We will send you guys an email with a link along with a PDF of the PowerPoint slides, so you have them there as a reference. Also, you can find a PDF of the PowerPoint slides in your handouts tab in your GoToWebinar panel. So if you do need to reference them, they are in the panel. All webinar attendees are in listen-only mode. And if you have any questions, you have a questions panel within your GoToWebinar panel. And please submit your questions there throughout the presentation. We will allow at the end of each session or each talk, there'll be a few minutes for Q&A, as well as at the end, we will have that open discussion and round table. What we're going to do for those of you that are in person, we will get your questions first, and then we'll go ahead and take the online questions through the questions panel. We'll have about 5 minutes in between speakers just so we can transition. Again, we have a couple speakers live in person, and then we have a couple speakers online. So just to enable that time for transition. And then moving on, Your GoToWebinar control panel, as I mentioned, your audio, you will notice that you are muted. The handout section is underneath, or it could be below the audio, but that's where the PDF is. And then there's your questions panel. So please submit your questions in that panel. If you guys want to change your webcam views, there's options at the top of the webcams. You can view who's talking, you can view whoever's on the webcam, but you can also adjust your screen size. So just some tips with regards to GoToWebinar. All right, with that, I'll turn it back to Kima to introduce Scott for our first presentation.
Okay, thank you, Amy. So our first speaker is Mr. Scott Thompson. Scott is the Executive Director of the Oklahoma Department of Environmental Quality, a role he has served in since December 2013. Prior to his appointment as Executive Director, Mr. Thompson was the Director of DEQ's Land Protection Division and has been with DEQ since it was created in 1993. Mr. Thompson has overseen many programs within this agency, including Superfund, brownfields, and voluntary cleanups, and he is also responsible for reimaging DEQ's permitting and enforcement process to better serve Oklahoma. Mr. Thompson holds a bachelor's degree in biology from Central States University and a master's degree in environmental science from the University of Oklahoma. So over to you, Mr. Thompson. Welcome.
Thank you, Kima. So, yeah, we can go to the next slide. Yeah, I'm so old that they changed the name of my school after I graduated from it. It's now UCO. Okay, a few years back, I started hearing about PFAS, perfluorinated compounds, Teflon and AFFF foam, PFOA, PFAS, dozens of acronyms. But it all kind of started from my perspective as Vermont primarily is the first state I remember talking about it. And Minnesota also got in on the act at some point pretty early. But there have been some releases around manufacturing sites that use these compounds for waterproofing or fire retardation. And the EPA Region 1 laboratory was set up to test for these compounds. And they offered free testing to the states in Region 1, which are pictured here. So, you know, that came up at some national meetings. There was some activity, there were some releases there. They were trying to understand it. And then later on, they talked about it again and noted that they could treat many of these compounds, or the ones of concern that they were seeing at that point in time, with activated carbon, just filtration. And so that sounded simple, really, not as challenging as a lot of compounds like chlorinated solvents are very difficult to clean up in the groundwater. And so things progressed from there over time, kind of slowly. These states, I think, believed that they had, 3 or 4 locations that they actually had significant releases of these compounds. And a few more states kind of started taking a look and had the capacity to look. And the equipment, would cost to set up for a laboratory to run that now would be on the order of $1 million for the equipment and for personnel to get up to speed to be competent in it. And then you'd have to have continued funding to maintain the equipment and especially to have the staff continue to work. So no other EPA region offered this kind of sampling for a number of years that I'm aware of. And later on, there was the new administrator of EPA, Michael Reagan. He hails from North Carolina, and they had some issues with a compound called Gen X, which is in this class of compounds. And that got a lot of attention, and I'm sure it took up a lot of his time when he was running the state of North Carolina. He also started out in EPA's research labs, I believe. He worked at Research Triangle Park for EPA for a number of years. And so I'm pretty interested to have him around because I like the research lab folks and people who have state experience. He also has some private sector experience, so we're pretty happy to have him in that role. So, you know, some of these places, they started having discussions with lawyers and talking to the manufacturing facilities or the original manufacturers of the compounds. They started getting settlements. And all this began, and EPA had not established standard test methods for these compounds in drinking water and other media. There was some testing occurring under what's called the uncontaminated monitoring rule, contaminant monitoring rule, UMCR, that EPA does from time to time. They sweep through, and we're scheduled for some more tests under that. So we're going to get more data on systems in Oklahoma and see kind of where we're at in that regard, as EPA does that testing. But, you know, there really weren't standard test methods developed, and there weren't test methods for other media. It's one thing to see very low levels in very clean drinking water. It's a whole different animal to start looking for that in media that's dirtier, because you can get matrix interference from other compounds that come out at the same time. Basically, a GCMS, a gas chromatograph mass spectrometer, is a time and travel thing about, you know, certain compounds migrate through the column at a certain speed and they come out at this point in time, and the height of the peak gives you an idea of the concentration. And so if you have a large peak somewhere, you can't see small numbers of compounds around that peak because the base of it kind of swamps them out. Or you can have other things, the amount of organic carbon and such, and in the media can cause it to be more difficult to achieve low detection limits. Anyways, we can go to the next slide. You know, and I think at the time this started, there wasn't a lot of talk about the numbers. I think people were mostly looking at the parts per billion, maybe a little bit below a part per billion, but that's kind of a reasonable range to do a lot of testing in these days with the kind of equipment we have. So, and some of this began because, and some of the other speakers are going to give you much more accurate, more detailed information about the toxicology and the history of these compounds. I'm more of a generalist, and I'm looking at it solely from the regulatory perspective. Like, what does this mean for us as a regulatory agency in terms of dealing with industry, with local governments, and particularly with small systems for drinking water or wastewater or et cetera, or solid waste. So the common term that I use all the time, because I can't keep straight all the little acronyms for all the individual compounds, is PFAS. It's perfluorinated compounds, and again, Andrew will fill in the blanks about some of the other things that could be there. So there are thousands of these that we use in everyday life here in America and around the world. Again, fire retardants, waterproofing, stain resistance, food containment. That means if you're wearing a Gore-Tex jacket, for example, if you're wearing waterproof boots, if you're wearing stain-resistant dress clothing, if your carpets are stain-resistant, if a lot of these surfaces in your car are coated with stain-resistant material or fire-retardant materials, then that's many times PFAS compounds that are designed to do that. These compounds can be kind of designer compounds, and the sampling protocols, because there are thousands of these out there, now the focus by EPA to date, it started with 2 or 3 compounds, went up to about 5 or 6, then we got up around 10 or so. I think at this point we're around 30 that they've developed test methods for, or about to have the test methods for, again, primarily in clean water. So there's a lot of states out there and a lot of folks that are doing testing in other media, but they're probably having to create their own method. And when we do government regulatory work, particularly for the drinking water program, particularly for public water supply systems, we only really rely on EPA validated test methods to make sure that the data we have is real. If you have false positives, you can create all kinds of economic havoc. Think about the people that are dependent upon clean water, hospitals, schools. You assume all the water coming out of your tap is just fine. But if you're running a restaurant, a movie theater, that sort of stuff, and we do testing on bacteria. If somebody gets a bad sample on a bac T sample on, say, a Friday afternoon, well, we usually duplicate that sample to make sure it's real. But if you do it on a Friday afternoon, you may wind up having a boil order and shutting down some of your economic engine for a city. Restaurants may have to shut down. Everybody else may have to go. Nursing homes, et cetera, may have to try to find an alternate water supply for a short period of time until that's determined to be real. And if it's real, actions are taken to try to resolve that issue. But many times the sample's taken at a bad spot where they randomly select a sink at a gas station or something, and it's just really, really grungy. And why anybody would choose that sample point, I don't know, but it does happen. So anyways, it's really critical in government work not to have bad data, because we can't make good decisions with bad data. And for example, in the sampling protocols, I'm most familiar with Ohio's. I tried to find a copy of that, but I couldn't locate it on their website this week. But they put out that pretty early compared to most states, and they'd really thought their way through how to take samples for this, since it's so common. And even though you may target a few of the compounds, you could easily get bad data because you get cross-contamination from the PFAS compounds that are not necessarily targeted, that may not be believed to be as toxic. And so much of this stuff, this movement on PFAS, was generated from some studies in Scandinavia, I think in Sweden, where it was indicated there was some data that there could be some human health effects, and everything kind of snowballed from there. But we're treating these compounds very differently than we have anything previously. And some of the toxicologists I've talked to have stated that, the data didn't necessarily support the level of action that we're taking on these. And I'll get into that in a minute, but let's go ahead and go to the next slide. Okay, so there's been a lot of discussion and a lot of debate. EPA's Office of Research and Development laboratory folks, and the way they set numbers, they came out with some recommended levels for exposure to total PFAS or several PFAS compounds together at about 70 parts per trillion. Well, that was quite a bit lower than anything we've looked at in terms of drinking water standards before. We're just getting into, the last few years being able to really test at these levels for certain things. And so there's been a lot of debate about whether EPA's number is correct. I had no reason to believe there was any politics in setting that number. That came out of the scientists. And in part, trying to make sure they had valid data, that they could really see at that level and know that what they're seeing is probably accurate. But then other states started pushing for drinking water standards and going as low as 10 parts per trillion for some things. A few states want to go below 10 parts per trillion. I'm not sure that is really possible on a routine basis with real media and not just some extremely clean media that you're testing in the lab. So EPA was scrambling really hard to try to come up with some test methods and to get into the debate about, what to do. And one of the concerns with running a drinking water program, if you set numbers that are impossible, nobody's in compliance. Nobody has a chance to comply. The public gets very confused when they see the information out there. And all this debates about which part per trillion you go with. Some states were going with 30. I think Minnesota went around 30. Then all this debate is really about assumptions. It is not necessarily about the data. I mean, your data is at a much higher level, and your assumptions take several orders of magnitude out of that, and conservative calculations, et cetera. You could easily have 3 to 5 or more orders of magnitude of safety built into the numbers that come out, and that everybody's arguing about what the science is. And that's kind of how a lot of environmental standards are set these days. The problem is, before we even gather data in these concentration ranges, the risk assessors are pushing, or certain other parties are pushing these numbers so low that it's really just theoretical. And trying to implement these kind of numbers in drinking water systems is really difficult. We have, for example, we have 1,361 public water supplies currently in Oklahoma. 377 of those serve from 100 to 500 people. 415 serve less than 100 people. So over half our systems serve less than 500 people. Their ability to generate funding to pay for existing things that they already have to try to do and keep up with in the drinking water program is very limited. And EPA generally does not provide much money. We do get some money, and we do some loan programs through the DEQ, and the water board does the actual loan and does the bonding and kind of gets to leverage that money and get more money for our systems in Oklahoma. But moving the ball really fast on drinking water is very challenging and is not very efficient, because if we're overestimating the risk here, maybe we're not dealing with the actual true risk from some other compounds. So it's just challenging. There's probably no right answer. Nobody can prove their numbers absolutely correct. And so there's debate, and there's a lot of want to in different ways. A lot of the folks that are in the arguments nationally don't necessarily understand what it takes to actually implement these numbers within a drinking water program. Again, I alluded to the settlements earlier. A lot of folks' motivation to push for drinking water standards early, because I think they believed it would increase the value of their settlements, increase their claims for harm in their states. And for example, Minnesota got, I don't know, a huge settlement from one of the companies involved. And then they were taking samples, and they determined that nobody had vetted that the new instrumentation they'd paid so much money for out of their settlement money didn't contain PFAS components, because, pretty much to take samples of this or to analyze samples of this, all the things that we've used since the 80s in terms of EPA's protocols for taking hazardous waste site samples or Superfund samples or even drinking water samples, we used lots of Teflon, Tyvek suits. You can't wear those and pull these samples because you could get cross-contamination. Many of the gloves that we wore, you can't use. You're supposed to, like, according to Ohio's thing at one time, you had to wear like 100% cotton clothing that was washed in a certain kind of detergent that had no PFAS components like 15 times. And that's what you're supposed to wear to go pull these samples. So we're sitting here, believing we can achieve 10 parts per trillion and be certain of what exactly we're seeing and what we're not. And that's probably not accurate much of the time. We can achieve those detection limits in the right situation. But again, implementing these kind of numbers day to day in real water systems and trying to fund just the testing and analysis. I'm not sure what the capacity is currently, but when all this started, even after we've been going for a couple years, there were only a few labs in the country that could analyze at these levels. And if one state had adopted a drinking water standard and started testing all their systems routinely, it would have completely swamped out the lab capacity in the whole country. And so as you have to develop standard test methods, you have to develop capacity to do the testing. and then systems have to pay for it somehow. So it's that makes dealing with these compounds and with our system of making kind of extreme assumptions very difficult to implement and very costly. So we can go to the next slide. So one of the things that caught my attention after it's been going on, I was happily ignorant that just assuming that we could treat this material in water with activated carbon and then maybe burn that stuff or put it in a landfill without having to worry about it too much. Well, Dr. Ken Eade gave a presentation which I attended, and he was really good and he was very knowledgeable, and I learned a lot from just that one presentation. He mentioned that it takes 1,000 degrees centigrade and 3 seconds resonance time to combust some of these compounds. And we're not even sure that gets all of them. And then more recently, I've talked to EPA's ORD folks about whether they've vetted disposal technologies. And one of their experts had told me it may be higher than 1,000 degrees and maybe more like 5 seconds for many of these compounds. And 1,000 degrees centigrade is hotter than many or most of the hazardous waste incinerators burn. And municipal incinerators are not set up for those kinds of times. So, and that temperature. So, you know, some of the states have been doing these cleanups or ordering companies to do these cleanups, or local governments having to do these, treat the water or even dig up soil and such. We're sending this material to municipal incinerators and solid waste landfills, and may still be doing that in some cases. So my understanding is there's about 12 incineration facilities in the US that can actually achieve that kind of temperature and resonance time. So that also puts a big bottleneck in the system in terms of, if you're going to manage this material, how can you manage it effectively? And some of the states that are pushing these very low numbers have been doing that and sending this material to places without actually vetting whether it was a good idea to send it there. And then there's a lot of stories out there about seeing PFAS components in leachate and sludges of different sorts, et cetera, in surface water. People are testing fish. And all of that is pure research at this point, really. Again, this EPA has not vetted this, standard test methods for those media and has not really verified that the kind of numbers people are claiming or whatever are seeing. And EPA also has a responsibility, which most of the time they pay attention to, that if they go too far too fast, they can cause train wrecks. For example, if you were to adopt a water quality standard for these compounds that's at an extremely low level, that's within the noise level that you're going to see from the kind of what's normal in the modern world, then if we write that into a discharger's permit, if it's determined later that that was not a good number, that that was an error, that that's putting us down in some level that can't even be managed, we can't back up. We can't take it out of their permit because there's an anti-backsliding provision in federal law. And so it makes it harder for you to take a risk at going for the lowest number you can get to in those situations, because if we were to do that to, say, a municipality, they might not be able to discharge. They might have to give up treating wastewater. And so that could just be crazy. But right now, much of this stuff about the other media, there's some data out there. I don't know that it's all been validated, and how you even manage it, what it even means, is up in the air. And I don't think we can keep using the 10 parts per trillion detection limit for a lot of these media. So we can go to the next slide. Okay, yeah, again, if you try to manage all the normal waste stream that has some incidental PFAS compounds in it that are not necessarily the handful that are targets of concern right now by EPA, there's no way to manage it. There's no capacity for incineration. There's very limited capacity for that anyway. And the transportation costs would be extreme. If you were to try to manage all that separately in the normal levels, then the volumes of trash and everything else that you get, because there are food wrappers and things that are coated with PFAS. In fact, I think a lot of the data from early days from a lot of drinking water wells and things, probably nobody vetted whether or not there were PFAS components in the pumps or in the tubing, if there were coatings on the well casing or tubing that contained PFAS. And for example, this sample, under EPA protocols for organic compounds, we used to use Teflon liners in our sample containers to seal them well, because that gave us the best data for everything except PFAS compounds. So, it's a whole new world in terms of trying to really manage this and truly implement any kind of standards. So we started looking at this, started thinking about the disposal end of this, because most everybody was just thinking about the front end, and people weren't really thinking their way through, what are we actually going to do with this that can manage it properly? And had some discussions at the national level, listened to stuff other folks did. There's a lot of claims out there about technologies that can achieve below 10 parts per trillion for water treatment or for incineration. And some of those I think are really working, and some of them I think are not. I haven't seen anything that makes me believe they're valid. So there was someone pushing thermal desorption for that. And I'm sure you could get some of these compounds out that way, but I don't know if you can achieve the kind of numbers that they say. And then you still you got to capture those in some other media, like activated carbon or something else. And then you've got to manage that. And so how do you do that? But our focus in Oklahoma has been on trying to make sure we're not getting long-term liability in our disposal facilities from some of these remediation sites, or people having to dispose of, say, AFFF foam. That foam is used for firefighting, and it's still required under FAA regulations. And if you want to stay in compliance with FAA and get insurance, and your banker wants to keep doing business with you, you've got to follow those rules. So on one hand, we're kind of banning PFAS, certain PFAS compounds in certain uses, and attaching tons of liability to them. But on another hand, we are really not getting that sorted out. So it's kind of a crazy time. And I was telling some of the folks in industry and local government, maybe 3 years ago or so, that this is the next big environmental deal that's coming at us. This is like PCBs were in the 80s. This is like, dioxin and stuff was for a while. This is it, because this is kind of the worst case scenario, because some of those other compounds may be around in some of our modern world, but they're not ubiquitous like PFAS compounds are. And so we introduced a bill, Senate Bill 622, which would have required a notification to DEQ of high concentration wastes being disposed in the state, and establish some generator liability. And basically, we wanted to require the generators and or the disposal facility to vet that how they were going to manage this material made sense. It was a good idea, and probably would manage it properly. And we wouldn't just be moving it from one media to another. And New York's done a test recently around one of their incinerators. It actually gets pretty hot, so it should be okay. And then according to their data, they're not seeing significant differences in soil concentrations around the facility, upwind, downwind. And they say it's below their level of concern for PFAS in soil. I haven't gotten familiar with what those numbers are at this point, but that information's out there about that particular incinerator. I think it's an old cement kiln that's been converted. And my understanding is in parts of the incinerator, it gets up to 3,000 degrees Fahrenheit, which is hot enough to do the job. So anyways, the bill was going through, but we had some crazy times, like, you know, most years are kind of crazy to the legislature because thousands of bills get introduced in the beginning. And the bill really didn't receive significant opposition. It did not make it onto the floor of the Senate on the last day. It was kind of a snafu in terms of somebody pulled up the wrong version and we had to try to get that corrected. And then there was a log jam of other bills. So we will probably try to run that again next year. In the meantime, we're going to do some rulemaking and consider and work with folks on how best to manage PFAS in Oklahoma, and to try to keep from, you know, we can't limit out-of-state waste dramatically. We can if there's a legitimate reason to or a legitimate cost associated with it, we can charge more. But basically the interstate commerce clause has been applied to trash too. And that means you can't really interfere with interstate commerce for waste, but we can establish standards for PFAS disposal in the state that's kind of across the board and take a harder look. For example, we have rules that sort of limit the amount of conditionally exempt hazardous waste that can go into our landfills. And so we can legitimately screen out-of-state waste and make sure it doesn't contain those items either before it can really be disposed of in Oklahoma in a big way. So our goal is not to take on, let's say, New York's or New Jersey's liability forever for these compounds, have them send that stuff here and then we're just stuck with it for eons, especially if it's not going to stay put. And the science isn't there yet to fully understand all this or to set really good hard numbers on this, but we're still going to try to focus on making sure we understand what's coming into Oklahoma and not taking things that just don't make any sense for the disposal site or technology. We have several landfills that, you know, most of the modern landfills are built really well and run pretty well, and not overly concerned about the operation or the facility itself. It's just if they get some stuff that's, you know, liquid, high concentration and high volumes, that's going to go somewhere. It's going to wind up in a leachate and could eventually wind up somewhere else. And so we have a municipal incinerator in Tulsa, and that's a concern. We have one hazardous waste landfill in western Oklahoma. And I think those folks also own one of the 12 incinerators that can actually manage this. So they're looking at ways to concentrate PFAS compounds and I think ship them to their facility or another facility that can achieve actual destruction. So much of this is really up in the air, and it's not, you know, totally validated. Nobody has exactly the right answer. Many people will claim that their answer is correct and that what they're saying is science, and anybody who opposes their number or their methodology is not doing science, but that's not really accurate. For much of the time today, what passes as science in the old days would have just been considered a hypothesis and would need to be tested and validated. But, you know, to a degree, we can't afford to do that with everything. And you do want to err on the side of safety, but the question is, how many orders of magnitude can we do? And if we start going down to the parts per trillion for everything, if this is the future for all new compounds of concern, then we're going to have some serious problems with implementation, and especially with local governments and small rural systems for drinking water and wastewater being able to comply with that. And really the disposal facilities, landfills, et cetera, they need some fairness too in the way they're treated, because, you know, they're following the rules, both state and federal regulations. And if they're doing that, then and somebody decides to push a number down way below what's the normal range, then that could be very problematic. And I'll give you another example of sort of this assumptions in lieu of real data and sort of valid scientific decision making, or using the full scientific method to test your hypothesis before you decide what's what. And if the data doesn't fit your hypothesis, you either modify your hypothesis or you give it up and you come up with a different one. And so for many, at least a couple of decades, if not 3 or 4, at least 3 maybe, EPA has used a screening level. In Superfund, where I kind of grew up in the regulatory environment, we, I took risk assessment classes. I worked with toxicologists every day. We went through and did risk assessments on sites. And so I understood that methodology pretty well. And it seemed a little crazy, but it was the best anybody could come up with for things we don't have all the data we wish we would have. But on the other side of the coin, there was risk management, because the old guys in EPA who wrote all these rules and implemented all these programs in the beginning understood that the risk side was pretty iffy. It wasn't absolute science. It wasn't validated. And so there are times when you could only do so much. So they called that risk management. And they were allowed to make decisions that considered the risk numbers, but understood they weren't necessarily totally correct. Just because you had this level of this compound didn't mean you were going to have a specific health outcome. It meant there was an outside chance you might have that health outcome at very, very low levels. Back then, low levels might be parts per million or might be down into the parts per billion. And, I wish I could remember the gee whiz numbers, but if you look them up, there's lots of stuff out there about, I think a part per trillion might be like a meter. Andrew can correct all this later. Might be a meter, 1 meter in the circumference of the Earth or something. And so it's just, it's kind of crazy. A part per billion is like 1 drop of water in a swimming pool, an Olympic-sized pool, I think. Those kind of things are what we're trying to look at. So, if you go to part per trillion might be 10 or 100 Olympic-sized swimming pools, I forget. But that's the kind of concentrations we're trying to test for and validate, and then understand what it really means in actual life, et cetera. And to balance the kind of costs and expenses we have for that with where's that money really going to make the biggest difference in terms of human health and the environment? If we're spending it all on this compound in this place, what are we missing? Are we really missing some things that would make a lot bigger difference with those dollars and those investments and that focus? So it's always a challenge to try to do that. But the EPA came up with these screening levels to try to help the regular staff, so we didn't have to run the risk assessors every day, to give us a list of things that, well, if a compound exceeds this number, it might be a problem. And then, of course, those screening levels devolved into de facto cleanup levels a lot of times. And if you ask the risk assessor what cleanup level we need for this, they would cite the screening level. And even if they'd used another number 100 times, they would cite that screening level to start with. And so EPA developed a screening level for arsenic in soil of 0.45 parts per million. But the problem was some of the old studies that were very widespread, had a lot of data across America, across North America, had established the background level across the US on an average about 7 parts per million. And then I can't find those studies anymore online. Maybe they're there, but they used to be readily available. Now there's a newer study that does just a couple of big transects across the US, and it says the average background concentration in soil in the US is about 5 parts per million. So EPA's screening level is at least 10, 11, 12 times below the average concentration in US soil. And it's probably maybe 15 times below what the real average concentration is for arsenic. And so when EPA did the response to Hurricane Katrina, one of the risk assessors was kind of joking with us about that. After taking 10,000 soil samples, they finally found one below their screening level. And the problem with that is that's put out there and people believe that's an accurate number and that it's really science to use that number, but it's nonsensical. If you try to apply that number to a real world site, you would never run out of contamination. You would assume everything's contaminated and we would wind up digging up all of North America. And then how are we going to grow food if we don't have any soil horizon left? Where are we going to put it all? Are we going to have to fill up, the Gulf of Mexico or something, or part of the ocean to manage it, or build a giant mound somewhere and cap it with, I don't know what we'd cap it with, concrete, I guess. So, and EPA risk assessors don't look at background most of the time. Some state ones might actually look at background, but background was not considered in setting that screening level, which is kind of crazy because, that does not represent an excess risk. 0.45 parts per million for arsenic is kind of meaningless in terms of real world application. And if EPA is paying for the cleanup themselves, they go up at least a couple of orders of magnitude almost every time. But you start a new site, you talk to the risk assessor, or EPA's making a private party do it, well, they start with that 0.45, even though it's not realistic. So it's kind of crazy where we're heading in terms of the potential ramifications to actually trying to manage this stuff and to implement these things. But that's where we're headed. So, as this occurs, there's going to be liability attached to these concentrations in these compounds, certain ones anyway. Many of the replacement compounds, I mean, if you take away all the fire retardants, you're not doing anybody any favors if there's actual fires. Like if you have a fire in a theater and you took away all the fire retardant, then that's not good. People could really die, like now, not some theoretical health effect down the road. So we have to replace it, but the replacement compounds are shorter chains of PFAS compounds for the most part at this point in time. But it's going to take time to find things to replace the uses of these and about whether those things are safe. And my understanding, the shorter chain PFAS compounds are even harder to break down than the longer chain ones. So I'm sure you'll get a lot better information out of some of the speakers to follow me in terms of accurate science and the state of the art, what we know now and what we can do now in terms of laboratory analysis and investigation and assessing actual risks. So I think I'm pretty much done there, so we can entertain questions if there are any.
Great. Thank you, Scott. Aaliyah, I will go ahead and hand it over to you if there's any questions in the room, and then we'll take the questions that have come in through the questions panel. Again, don't forget to submit your questions through the questions panel for Scott.
And the slide that's up here, the ECOS Environmental Council of the States has a large website devoted to PFAS, a lot of links to other states and what they're doing currently, and probably some of their protocols for different things. And again, it's all over the board from state to state as to where we're at. I would say in Oklahoma, we're waiting for the EPA to develop national numbers and standards and procedures, because you just can't, there's no point in getting ahead of that national deal, because whatever we do, except for trying to get in front of some of the disposal, we're going to rely on EPA and their research laboratory folks to really help us understand the best path forward.
Aaliyah, are there any questions in the room?
Does anybody have any questions in the room? Please raise your hand and I'll come over and. No? Okay, no questions here.
All right, we did have a few come in over the questions chat box. The first one is, what is Oklahoma's position on developing own drinking water, wastewater, and/or biosolids standards?
Again, like I just mentioned, we're going to rely on EPA, and we are one of the states that adopts federal regulations probably as quickly as anybody in the whole country, because we're going to stay current with federal law to maintain our delegation of these programs. And there's just no point not to, because you've got to do it if they adopt it in a regulation or in statute. So they have a lot of expertise. They have way more resources than we do. And whatever numbers they come up with and decide will be legally required and enforceable.
Great, thank you. Scott, there was a question that came in, and they say that their company recently got a question from our liability insurance company if PFAS chemicals have been used at our facility. Has that been seen within other industries yet?
You know, I haven't heard that, but it does not surprise me. That is typical, as, you know, there's a lot of media attention on these compounds. There's been some releases at DoD facilities, and so there's a lot of stories out there in New Mexico. There was some impacts to a dairy next door to an Air Force base, and there's a lot of controversy over that. And you know, the folks that are running the state of New Mexico have been wrestling with that for a year or two, and there's always that challenge. So, you know, insurers, bankers, everybody's going to become more aware of this, just like in the old days when all of the environmental regulations started. Suddenly, the private sector required even more than the government did in some cases to understand what the risks were or what the history of a facility is. EPA has currently talked about bringing up drinking water standards for 2 of the compounds, Teflon, I think, or PFOA, and PFAS. And PFAS may be the AFFF foam, I think, or a fire retardant. So anyways, those are the 2 they've focused on for drinking water standards in the immediate future. And so as that develops, we will follow that and interact with EPA and other states on setting those standards. You know, you'd have to ask some of the other industry folks about the insurance.
Right, right. Okay, another question came in. Is SWMAC going to start the rulemaking soon?
We're going to put something out there. Patrick's here, and he could give you a much more accurate information than I can. Patrick Riley works for us and runs our solid waste programs, and so he'll be the one that works through that stuff with our Solid Waste Management Advisory Council. But we're going to put some stuff on the table and begin discussions about it, not necessarily actually voting on any draft rules. You know, we'll do that this summer, and I anticipate that we probably won't get things through really fast. Part of our intent to introduce the legislation and to have the discussion about potential rules is to elevate this issue with industry and the disposal facilities, because, you know, basically there's a big train coming at us all, and that liability is is real. And you know, whether or not the number is completely accurate that somebody comes up with doesn't matter as much as the liability does, in terms of what you have to do, how you have to implement things, and that we should be prepared, and we should try to avoid doing things that increase that liability in the future for Oklahoma and our facilities and our local governments.
Thank you. Okay, another question just came in. What is DEQ's position on disposal of PFAS in underground injection wells, non-hazardous?
I'm not crazy about that. It depends. If you had, you know, we have a lot of disposal capacity in UIC, underground injection wells, but mostly in class 2 wells for saltwater from the oil patch. And those are regulated by the Corporation Commission. Most of the other UIC wells that are actually permitted in Oklahoma are under DEQ's purview. There's a few in Osage County that are EPA's authority. And most of those are class 2 wells. I don't know that there's any up there that are not class 2s, but I don't think that technology is proven yet. I know there were some folks trying to push that, trying to change federal law to make that the answer for these compounds. But, you know, if you put it downhole in the right formation, it's probably never going to be a problem. But Oklahoma has so much historical drilling that, you know, much of Oklahoma is kind of Swiss cheese. So for the wells that we permit and the other classes for UIC, we have to validate that the pressures at that level don't exceed a level which would push, could potentially, if there's a fracture in old wellbore that's not properly sealed or identified or et cetera, that we don't want the pressure to reach a level that would be able to push those contaminants up that escape route into more shallow zones, especially drinking water aquifers, et cetera. And there's a prohibition against injecting through certain, you know, potentially usable drinking water aquifers or usable drinking water aquifers. So that is much more challenging here than it sounds originally, but you know, that may be part of the answer for certain compounds, but I think it's got to be done properly in order to be safe.
All right, thank you. Just a couple more here. I think we're still okay on time. Are there many PFAS contamination sites in Oklahoma?
Well, not too many that we know of. DOD has done some testing. A few cities have done some testing on their own. Our laboratory, we don't have the funding to acquire the equipment, et cetera. So I was trying to push EPA to put the proper equipment in the Houston laboratory in Region 6. And that never got funded because I was sitting there going, well, they're doing all this work in Region 1 and you ought to be providing that same level of service to everybody else, but that hasn't happened. I don't know if any other EPA regional laboratories are doing that kind of work for other states, but we do have a private lab in Oklahoma, I think in Stillwater, that can run the test. I don't know for sure what their detection limits are, but I think they can get down into that range.
All right, I think one more. And again, if you have your questions, please submit them in the questions panel. Regarding the disposal bill of State Bill 622, how many PFAS compounds will be looked at?
Well, we didn't have really definitive numbers or didn't identify specific compounds in that bill. We were going to leave it open as the federal rules and such developed and the science developed, that we would be able to modify our rules to include those. But what we were really trying to capture was high concentration things, like somebody trying to dispose of AFFF foam that's either been spent and used or that hasn't even been used yet, and they're taking it out of their facilities because they don't want to mess with that particular PFAS compound because it's already under, you know, national scrutiny. And so we were going to try to go after high volume, high concentration PFAS, and we would probably look at the short list that EPA has developed so far of from 6 to 30 compounds and try to make some determinations about those. But we were not trying to capture all the normal levels of PFAS and everyday stuff that nobody can really even manage or test properly for. And so it's going to be an iterative process a little bit. We're probably not going to try to nail stuff down in statute, but rather give ourselves, or have the legislature and the governor, if they're willing to, give us the ability to do rulemaking. And our rulemaking is very open in Oklahoma. We have these citizen advisory councils that we kick things around with all interested parties. We have a variety of folks that are represented on our councils. If potential rule comes out of a council, it may have multiple discussions. It may not get anywhere in the council, but if it comes out of the council, it goes to our environmental quality board. If it passes our environmental quality board, there's public comment input at every step. Then it goes to the governor's office and the state legislature for review and approval. So it can take a while to get a rule in place here, but it's a good process because it keeps us from writing things that don't make sense or don't work. And it gives everybody a chance to have some input into that process. So I would encourage you, if you're really interested in this, to pay attention to what's going on with our Solid Waste Management Advisory Council, and especially the next few meetings, and try to attend those, or at least follow up on what's happening there.
Great. Okay, one last chance for questions for Scott Thompson of the Oklahoma DEQ. Remember, Scott will be joining us again at the end of the session for an open discussion roundtable Q&A. So if you happen to get one in at the last minute and we don't get to it today, then, or excuse me, during this time, we'll answer it at the end. Scott, anything else?
No, I think that's it. Thanks for having me. Thanks to OSU for having this event, Kima. I just, it's something we all got to pay attention to, and it's undoubtedly going to change over time. And again, Pete and Andrew and the folks that are following will give some really good information. I'm sure this is going to be a valuable presentation for you.
Great. Thanks so much, Scott. We really appreciate your time and all of the valuable information you provided. Okay, so it looks like we are a little bit ahead of schedule. I think with that being said, we'll go ahead and take a 10-minute break, let some folks fill up their coffee, stretch their legs, and we'll be back online at, we'll say 10:15. Thanks, everybody. Okay, everybody, it's about 10:13. We'll get going in about 2 minutes. Peter, I know you're on deck, so if you want to get ready, we'll start in about 2 minutes.
Okay. Test, test, test. Good.
This way and then turn.
All right, it's ready to go when you guys are.
Okay. Thank you to Mr. Scott Thompson for that wonderful presentation. Our next speaker is Peter Schultz. Peter received his BS from the University of Oklahoma in geology and his MS from Oklahoma State University, go Bucks, in civil engineering. He began his career with A&M Engineering in Tulsa, Oklahoma, as a project manager specializing in groundwater, geotechnical engineering, and air permitting. After a 15-year career in consulting as a project manager, Mr. Schultz began work with waste management as the regional engineering and compliance manager. During his career with waste management, he has been the regional engineering manager, regional environmental compliance manager, and the regional gas operations manager overseeing all the landfill gas collection systems as well as the landfill gas to electric facilities. He is currently the Senior Director of Disposal Operations for Waste Management of Texoma. He has worked for waste management for a total of 20 years. When Mr. Schultz can find time away from work, you can find him with his family lounging behind his boats in Grand Lake or competing in a KCBS barbecue event. Mr. Schultz currently resides in Broken Arrow, Oklahoma, with his wife, Lisa, and 4 children. So, Mr. Schultz, you're very welcome.
All right. Thank you very much. Appreciate Kima, you for inviting me, and OSU for having me. Really appreciate that. One of the things that through the years and being around Oklahoma for such a long time, you've seen a lot of things come and go, and it's been great to work in such a state, you know, and I've had the opportunity to work across the country in a lot of other locations dealing with, you know, regulations, and particularly in the solid waste industry. And I would have to say that Oklahoma has been a real pleasure to work in, not only the DEQ, but also, you know, with industry and government. So we've been really, really happy. So I am the senior district manager for waste management here in the state, managing our 3 landfill facilities and 1 transfer station. My career has kind of led me through many aspects of both the environment and engineering. And so, you know, it never ceases to amaze me, you know, how things can change, and new things that we never thought would be potential issues, you know, would come to light. So you can go ahead and go to the next slide. Okay, as most of us probably have seen this picture before, this is Johnny Cash, and he is singing and doing a concert at a prison. So, you know, a lot of times, you know, particularly when new regulations or you know, ideas come and hit the regulated community, you know, it sometimes feel like, you know, we're a little bit of a captive audience, and we don't have, you know, much say what's going on. And of course, you know, I was kind of thinking a little bit about the different, you know, music that might be played, you know, maybe something, you know, obviously Folsom Prison Blues, you know, actually maybe, you know, Cream was Crossroads, you know, these are things that, you know, Ring of Fire, you know. But one of the songs that kind of came to my mind, and actually I can take off my mask up here because I got this nice plastic in front of me here. But one of the things that came to my mind was, you know, there's a great song that Johnny Cash wrote about a Cadillac, you know. And so sometimes as a regulator, I can imagine, you know, everything seems to get pieced together, you know. And I'm going to kind of put my spin on it. As a child, my father worked at American Airlines here in Tulsa as a mechanic. And so he, you know, had his nice metal lunch bucket that he took to work every day. And I remember hearing this song and thinking to myself, you know, man, if Dad could, you know, cut apart a 727 and bring that home and put together, that'd be pretty cool. So, you know, but I think, you know, the point is that we have a lot of moving parts and components, particularly to the PFAS. Potential regulations and protecting the environment that we have to look at. So, you know, as we work through a lot of this, you know, the ifs, the ands, and the whats, you know, how do we do this? You know, do we, you know, really try and push regulations through as a regulated community? You know, what's going to affect us? Is it going to hit the bottom line? You know, we're particularly in the landfill industry, you know, a big part of what we do is to protect the environment, to make sure that we're not impacting our neighbors and hurting, you know, human beings. So, you know, the path a lot of times, you know, particularly in instances like this, can be extremely confusing. You know, there's a lot of information out there, a lot of guidance, you know, a lot of things that people are throwing out there, and, you know, what's right, what's wrong, and what's going to impact us, you know, the most in our day-to-day lives. But at the end of the day, the most important aspect of this is protecting the environment and protecting human, you know, life. And then you know, what we, as a regulated community, you know, we want to, you know, we're working for a business, you know, we want to provide services that help and impact in a good way our customers. So that's extremely important. So go ahead and go to the next slide. So what I wanted to do was talk a little bit about what waste management has at stake. You know, and you got to remember that even though Waste Management is one of the largest waste and recycling companies in the United States and North America, you know, there's a lot of other facilities that PFAS is impacting. and will impact moving on. But for us, right now, we look at 265 active Subtitle D facilities. As Scott talked about, one of the biggest concerns that we have is impacting, wastewater treatment facilities. The conversations that everybody's having very much has led, okay, where's the PFAS been going, and where is it headed? And so you look at and we'll talk a little bit more about that circle and where it's going from the perspective of waste facilities and recycling facilities. But landfills discharge more than 300 wastewater treatment facilities and accept residuals from over 500. And that's one of the things that we really have to ask ourselves when we're doing some of these regulations and thinking about the process. And we'll talk about it a little bit more later, is we take in a lot of wastewater treatment sludges. And so in the process, if our leachate or any other industry's wastewater is going to these water treatment facilities and then the sludge comes back to a landfill, it's starting to compound in concentration potentially. So, but we're going to talk about that. I have some limited information, but it's still, as Scott talked about, it's very much in its infancy. We're collecting information, not only waste management, regulatory community, but other industry entities and governmental entities are collecting this information and look at. So, one of the things that we touched on, or Scott touched on, is we have 6 Subtitle Cs, 5 landfills, 1 underground injection well. So are these potential viable options for this kind of waste material? So we'll talk a little bit about that. Manage remedial sites, provide disposal and private for government sites, municipal, and DOD in particular. So, one of the things that landfills, you really have to remember is that they're, as much as we wish we were better recyclers, and we need to be better recyclers, still a large portion of our waste products go to landfills, whether they're Subtitle D, Subtitle C, injection wells, incinerators. We still have a long ways to go, and PFAS definitely, kind of brings to light the potential for how a chemical might impact, the entire industry, not only landfill, but businesses, government. We've got 44 composting operations. You think about that, the potential aspect of that. Are we taking, wastewater sludges from water treatment plants and we're making mulch now? And so, what's the impact of that? Waste Management's the largest recycler of post-consumer materials in North America, including handling coated paper products. For us, that one of the first things that jumps to mind is the safety of our employees, safety of our customers coming in and out. And then these products, when they get reused, how are they being recycled, reused, the process, and if there's any, back end, potential impact from this chemical. So, and then hundreds of municipal partnerships. And that really entails not only from a wastewater treatment facility, but all of the small communities, that we provide service to, and so all the things that we do for them, recycling, disposal, composting, all those aspects, are potentially affected by this chemical and any regulations that may come, as a result as we move forward. So, there's a lot to think of, not only for waste management. This is really, it encompasses a lot of, our disposal options, recycling options, and can potentially impact it. So, okay, go ahead and go to the next slide. So what I'm going to do is I've got some topics I'm going to try and hit, and I know for the purpose of this workshop, we would love to have definitive answers at this point in time, but I'm not sure that we really are to that point. There's, and Scott talked about it, I'm sure everybody else will talk about it in the coming presentations. It's really in its infancy. Testing methods, disposal, best BMPs, best management practices. How can we do these? We need to start having these discussions, and that's really where a lot of my presentation is going to come is trying to think, how are we going to accomplish this? You know, there's a lot of ideas out there, not much technology. You know, we really don't have good idea on the disposal of this material yet. So, so I'd like to try and outline, you know, the solid waste program, maybe go over a little bit. I'm going to do some basic, you know, landfill 101, you know, and talk about where potentially PFAS could potentially impact it, places that we're looking at. And I know other industry landfill companies are also looking at. Waste regulations review, I knew Scott was going to be talking about a lot of this, and so I'm going to hit a lot of the same points and kind of and try and give you our perspective, waste management's perspective of where we're at. It's real not high tech, you know, at this point in time. We're waiting for the answers just like everybody else is. Handling and disposal, particularly the health of our workers, you know, and recycling, you know, that definitely potentially can impact that, and we need to identify it and address it. And then best management practices, you know, what I'd like to discuss is kind of what we're doing now. You know, what's the best management practices that we're working with based on the knowledge we have, based on the information that we have, and where do we potentially go with this moving forward. So, and again, it's a big guess, you know, because we're still waiting. A lot of people and states, governments, you know, the regulated industry are waiting for some guidance. You know, where do we go with this? So, okay, go ahead and go to the next slide. Okay, one of the things that, and you can go ahead and click through this, you know, I kind of had a line, but ubiquity, go back one. You know, it's a word. As I started doing a lot of research on this and, you know, started hearing, it seems to be a definition that's stuck, you know, particularly for PFAS is ubiquity. So I wanted to make sure, at least for me, I had to look it up the first time I heard somebody giving a presentation. I was like, oh my gosh, what is this? You know, but ubiquity is the fact of appearing everywhere or of being very common. So it basically is all those things that are very common, the thing, and you'll hear everybody talking about how this PFAS type compound has been in our everyday life, you know, particularly, you know, even me, for a guy with a lot of gray hair, it's been around for a long time, you know, since World War II, you know, and the use of it has been very wide ranging, and we'll talk a little bit about it, but it basically is everything, you know, and you know, carpet, you know, the materials that you had your Big Mac in, you know, and we'll talk a little bit about, I want to touch base on kind of where it's coming from, where we've seen it come from, and where we're not seeing it anymore. So moving forward, but I think this is a good term to get everybody to use, because it really covers the everyday material versus the high concentration material, you know, the firefighting foam, you know, that would have high concentrations in this type material. So, okay, go ahead and go to the next slide. Okay, solid waste programs. You know, the programs, and I'm probably going to talk mostly in the state of Oklahoma, because that's where my expertise is. I've got a little bit of knowledge of some of the other states and regulatory communities, you know, around the country, but programs that are regulated by the ODQ in Oklahoma are good. We've had an extremely great track record with the DEQ as business. The DEQ, particularly Scott and Patrick and their staff, has been very receptive to listening to the industry, not only the landfill industry, but other industries that manufacture and really pay attention to, you know, protecting the environment, number one, protecting human health, two, you know, and then two, we're in business. You know, it's important to the economy of Oklahoma to make sure that we're doing all the right things. And so, you know, one of the things to look at is the regulations themselves and what we are dealing with right now and what we have that we can use. And one of the things is subtitle D and C and D regulations are effective, you know, and I'm going to go over that. I've got a little bit of information about those kind of possible disposal, you know, possibilities, you know, but it's good, particularly in Oklahoma. You know, those regulations are solid. You know, we spent, I remember years ago, and I know a lot of the folks that are on this call and an event and some here locally when we worked on rewriting the regulations. We're for solid waste, particularly landfills. It was a great experience. It was very hard, very difficult. I don't look at, the PFAS regulations that we have coming up to be any different. We need to have those difficult discussions about what protects the environment and then what is good for our industry here in Oklahoma. And I think it's a model that a lot of other, governmental agencies and should really look at. There's a lot of great input. Oklahoma is very fortunate with the technology. We've been very lucky to have, oil field technology and that kind of funding to help us develop a lot of these rules and regulations. It affects the landfill community drastically. Multiple and redundant systems to protect the environment, and I'll go over that a little bit whenever we talk about kind of the landfill 101. Current regulations really do a very good job of being redundant in protecting the environment. And we'll talk a little bit about that and how it may affect some of the PFAS, thinking when we're developing these rules and regulations. The current landfill engineering technology has an excellent track record. One of the things, being a little bit older guy, remembering the days when landfills, particularly younger, it was you drive down the street, and the city municipality was digging a trench and putting trash, down in a trench and then just covering up. And today's landfills are a lot more modern. We have liner systems, detection methods to protect the environment, and so these are things to consider, when we're looking at potential regulations and in these discussions. So, but overall, I feel the solid waste programs that we have here in the state of Oklahoma and the EPA guidelines for those facilities are good. And we can talk one step further, even with the injection wells that may be a potential place for these kind of materials and liquids. There's fairly good track record. As Scott noted, Oklahoma's Swiss cheese, so we've got to really think about that kind of technology and using that as a disposal location. But it should be explored. Okay, go ahead and go to the next slide. Okay, so what I've got here, this is kind of the landfill 101 for folks that aren't very familiar with landfills. And I know the picture's a little bit blurry, but let's start at the bottom. The liner system. Typically, a liner system, and as I explain it to everybody, is similar to a bathtub minus the drain at the bottom, right? We put in, typically in Oklahoma, we put in 2 foot of clay, of a low permeability clay, some sort of synthetic liner, and then a drainage system to collect any water at the bottom. So through the years, if you look at the data, yes, there's been some failures, but if you look at the overall success of this technology and doing this kind of liner system, we've had very good luck with this. And so, I think that's important. The second aspect is the leachate collection, which is actually the component that really concerns us most as landfill operators, particularly when it comes to placing waste into our landfill that will eventually potentially end up in the leachate. Then we've got to do something with it. So those systems are very, very good systems. The majority, and typically the way those systems are constructed is that we'll have some sort of high permeable material at the bottom for 2 reasons. 1, to protect the plastic liner, and 2, as a passageway for the leachate that filters through the waste and then it's collected. There's many different ways that can be managed. One is that it can be recirculated back into the waste, and which of course in this topic adds lots of conversations about its potential ending the end result. But in the majority of the cases, I shouldn't say that, let's step back a little bit and talk about where are these landfills. Typically these landfills are located in more rural settings. The landfills over time have been permitted outside of cities in some places, and particularly in Oklahoma, Tulsa, Oklahoma City. Those landfills were originally permitted kind of out of the way. Now the city has moved out, right? Everything's growing. So that kind of has some issues that go with it. But the majority of our landfills typically aren't next to a POTW, which is ideally for a leachate system, is to be able to have it go to a water treatment facility to where that water can be treated. Okay, and then that in this conversation, it adds a topic. Okay, we're sending this leachate to the POTW. Can they manage it? Can they handle it? What are the concentrations? Do we know what those are? So those are the kind of topics as we move forward and try and come up with regulations that we need to ask ourselves. But typically these leachate systems are very effective. Okay, they're very good at collecting water. There's some applications, where you pump a lot of water. I'll use my my facility located in Tulsa, Oklahoma, which is called the Quarry Landfill. As you can imagine, it's in a limestone quarry, and the material that I have to cover with and use is a rock. And so when it rains or when we have a very wet year, I see a lot of leachate that comes through at the bottom of my landfill because it typically isn't covered. Of course, we try and put on our final covers as soon as we can to try and prohibit that. It becomes a cost, which is one of the things we're going to talk about. Is the leachate is going to impact our landfills for us potentially in these regulations more than anything, because the cost of disposing this could potentially be very high. And at this point in time, as we've all discussed, and we will continue to discuss today, is that there's no real good technology on how to dispose of this PFAS waste yet. So we're it's all new. Where's it going to go? And that's a concern for us, cost. Of course, then going back into a little bit more on the landfill, we come into the gas management system. Something that actually I was very fortunate that I got to work on and with, for many years. It's an incredible technology. Not a lot of people know what goes into installing a gas system into a landfill, and then potentially the benefits that you have. But overall, those rules were based on air quality to reduce odors, and the systems typically, if managed properly, work very, very well. And so, but then it comes back to, this is another topic of discussion, is that gas is in the waste, and so is there any effects from possible PFAS that's getting into it? Is the application of either flaring or burning the gas into renewable aspects, like through diesel engines or cleaning products? Are we cleaning that PFAS out, and where is it going? So this is a lot of questions that we don't have answers to. So and a lot of it has to do with testing methods. We don't have those. Really, the only testing methods that we feel somewhat comfortable with are water. So that's definitely an aspect as we move forward, with this and how it will affect. And then kind of the final, once you get everything on, is stormwater. So, part of our requirements as an operator of a disposal facility is that we cover the trash. Even on rainy days, we have to manage in all of our stormwater runoff. So will there be impacts for that? So these are all the questions that I know the regulators are asking, and we as the regulated are definitely asking, how's it going to impact us? So I'm gonna talk a little bit more about it, but there's still a lot of questions. We don't have all those answers yet. So let's see. Okay, go ahead and go to the next slide, please. And one topic that we can talk about from the previous slide is, the renewable aspect. One of the things that I know landfills across the country are really trying to work on is use the gas as renewable energy. And how is that going to impact that? Will it still be cost effective to do those sorts of projects and renewable things? But okay, waste regulations. Obviously Scott did a spectacular job of going over, and I'm not sure that I have much to add, but I'm going to try and put it from the perspective of a regulated industry and kind of where we see it. But as I talked about before, the PFAS type chemicals have been used since the World War II era, for many different things. Go ahead and go to the next. But for the most part, it's not till the early 2000s that it really kind of hit the waste industry, radar that this is potentially an impact. So what we saw, in that is we saw the stop using that kind of material. We still see it in the firefighting, but for the most part, the other products, people are trying to find other ways to get stain resistant carpet and fabrics and materials, typically in the United States. And I think you go to the next one. And that's, most of it's been phased out, from 2002 to 2015, but we do a lot of trade with other countries. I'm not going to go into it in too depth, but if you look at other countries' use of the materials, and a lot of that is imported into the United States, it comes to us. And this is where it really is the ambiguity of it kind of jumps in there. I mean, there's a lot of that that's not regulated. It's the small amounts, it's the day in and day out stuff that you put on the curb and that either gets recycled or comes to a waste facility that really is concerning, or is it? And so, and I think that's one of the things that we'll talk about here in a moment, that's kind of a challenge is, in mulling through all of this, is it really an issue? Yes, but at what level, and what level do we want to regulate it, determine what those limits are? That's really where we're going with all this. So go ahead and go to the next one. I picked this up, and I'm sure it changes, day to day, but we've seen significant reductions in bloodstream in US of this kind of material since they started phasing out a lot of this material, which I think is important. I think I talk about it a little bit later, but one of the things that we're also seeing is the concentration levels in landfills, is also starting to see a little reduction. Now, you have to remember that the amount of testing that we've done and amount of information that we have is very small. So the information I'm providing you is just a very small piece of the pie as far as what is potentially out there. And a lot of that is due to testing methods, and really researching and looking into what is there. So go ahead. One of the things that kind of tickled me a little bit, is that as a regulated, it's a great process, but the EPA has a plan. And if you get a chance to look at this plan, which is PFAS action plan is what it's labeled, it really looks more at technologies that we could potentially dispose, incineration, things like that. They are working on methods, they are working on limits, but we don't have any of that information yet. But the EPA has a plan. So if you get a chance, please read it. It is some good information. That this last plan, actually, I think it came out in March or early this year, really kind of outlines where they've been in their research and what they're doing. And so it's kind of a good starting point, but we still have a long ways, and in my opinion, we still have a long ways to go before we can really get to, put our teeth in this. So go ahead and go to the next slide. Oh, one last, states are developing regulations. That's one of the most important things. Scott talked about it, and I want to make sure that, there's definitely some kudos to go out to the state of Oklahoma when they were working on the legislation bill, the state bill 622. Very much were very open to comment and helping write some legislation for this. This is a very serious, potentially serious chemical that can impact everybody. And so in that, I encourage everybody to reach out. The EPA, has got, where you can, report back to them, have any comments, anything like that. Make sure that the industry, not only the regulated, but the regulators are reaching out to the EPA and kind of vetting out all the concerns on this. This is happening right now, and it's important for everybody to be part of the process. And so, but go ahead to the next. Okay, kind of what I spoke about before, waste regulations, there's a whole lot of guidance going on. of course, with guidance, it's guidance. Nobody really doesn't know, what we're supposed to do. And, the latest, as I talked about before, the latest EPA guidance is primarily covering destroying technologies. And here's the topic of EPA interim guidance on destroying and disposing of certain PFAS and PFAS containing materials in December of 2020. So this is great information, but as a regulated, as a business, how do I take this? How do I prepare for this? How do I, look to making sure we don't impact our facilities or cause ourselves further damage, moving forward. So these are all very interesting topics, and talking points that we need to have. So EPA PFAS Action Plan Program, February 2020. So, again, this information, a lot of the states, look, to the other states and see what they're doing. There's some good information, and particularly for the folks in Oklahoma, we've had the opportunity of some other, governmental agencies and regulated communities comment on this and see where it is, talk about the potential impacts that it may be. Okay, EPA has yet to establish an enforceable maximum contaminate level. Guidance is 70 parts per trillion. What is the right number? That's the the $1 trillion question, right? How do we determine, what that is? So, there's a lot of very smart people that are, working this out, and we've got to make sure that we're inputting and we provide information and data that we can really come up with a good solid number, and Scott talked about it. Wholeheartedly believe in that. We've got to believe in the process. So go ahead. Research is still ongoing for environmental risks and waste from 2019 EPA funded program. The EPA is looking into, how is this impacting, human life, when it makes it through all of these streams, whether it's, a product that goes to the landfill, that goes to a POTW and then is discharged into potential rivers, and then we drink that, how is it treated? Can that be treated before it's provided back to us? So those are aspects that we're still looking at, Go ahead and go to the next one. Several states have lower action in drinking water standards. Is this really going to impact? And it was kind of to my point. One of our concerns is that, are we sending liquids to a POTW that could impact their ability to manage it, particularly the smaller communities. As I talked about before, a large number of our landfill facilities are in small communities. And so the leachate that may be taken to that, could impact, that community. And of course, then the sludges that come from those water treatment facilities may impact our landfills. So go ahead. Several are working on regulations, and as Scott talked about, he's working on regulations in Oklahoma, and we've been very fortunate that the DEQ has reached out to us and asked for some input and how these rules and regulations could potentially look and how it could impact us. Again, number one is the environment, human life, and then the business, the structure of the state itself. So, one of the things that we have to look at, and I touched on several times, is we really got to look at how these rules and regulations can impact business. It may impact a landfill. The cost of disposing of liquids at a POTW may go up, but how does that impact everybody else? As I spoke earlier, wish the recycling was more prevalent, but as we know, a very small percentage, typically, I know there's numbers, but the waste stream that actually comes into a landfill is pretty small comparatively. So how do we manage that, moving forward? And it's going to impact business. It's not only going to impact the disposal and the recycling industry, but it's going to impact businesses, because their costs potentially could go up for managing. And it's not only at the landfill, but you got to think of all the industries that do produce wastewaters, that take these products, raw products, and then potentially have these kind of chemicals that may end up at the POTW, and then their costs are going to be increased to dispose of that. So go ahead and go to the next slide. Okay, this really, this is where, I talk about more from a landfill aspect, the ubiquitous type material compounds, which again are and you can go ahead and list through those, but it's pretty much, the cookware, food packaging, paints, shampoo, the carpet, clothing, contaminated soils, and, the small ones, but the ones that really concern us, and I believe that it's really the one thing that really concerns, the regulators, are the large things, the firefighting foams, the contaminated soils in bulk. And so one of the things that I'll talk about in a moment is, okay, right now, technically we're not really regulated, right? Particularly as a landfill or recycling business, we're left for best management practices for the most part, right? So, what do we do to make sure that we're protecting the environment and protecting our liability, as a company? And this will be something also to think as a business, the same thought process. One of the things that data it's not out there a whole lot, but a little bit that we've seen is that if you look at the loading of this material coming through the landfills, okay, for the very limited information that's out there for the amount of material, PFAS material, that goes into a landfill, the amount that goes out the backside of a leachate is extremely small, okay? Extremely important because a very small amount may, based on the regulations and how it's utilized on the back end, could be very impactful. But that raises the question and goes back to kind of my point on the landfill system itself. As we discuss this, our landfills, particularly Subtitle D and Subtitle C regulated hazardous waste facilities, is it potentially a good place for this material to go? That's one of the topics we need to talk about. We need to really think about is that, if you look at what's going into the landfill and then what's coming out the backside, is that impactful to where we want to set our limits? And so that's a good point to look at. There's not a lot of testing that's going on with this. We need to have better testing methods. I was looking at one study, and I don't have the information and I can put it out, but I think they were looking at one landfill and it wasn't a waste management facility, but for the testing that they did and the load analysis they did, they were showing that only 1% of the material that was coming in the front side of the landfill was exiting out through the leachate system. So it'd be interesting. Again, that's extremely limited. I mean, and for us, we have 300 or so landfills. I wouldn't venture to guess. I think the state of Oklahoma has around 350 to 400 landfills. Of course, that would include C&D landfills. So across the country, what are we seeing on this? And obviously it's going to be impacted by the kind of industries that are using the landfills. For landfills that have a lot high industrial waste going in, non-haz industrial waste, most likely we probably will see a little bit higher. Where we've got more I can't even say it, more of the common type material going in, then that's where we're not seeing as high numbers in those. So, and how's it impacting groundwater? Are we seeing it leave the facilities, through groundwater, through gas? Talking a little bit about regulatory, how things move and process, it reminds me of a story that actually happened to me, and part of my career path was that for those in Oklahoma may be familiar with or have ever heard of the Mosley Road landfill in Oklahoma City. It's a landfill that Waste Management purchased, and we later found out that it became a Superfund site. And so in analysis, looking at this, you take what you think is a true issue, but then as technology came around, in specifics, we thought we had, hydrocarbons, chains in the groundwater and arsenic. And so one of the remedial actions that we took was to put in a gas system. And it was mainly because it was permitted, per EPA regulations, the volume of the landfill was large enough that we required a gas system. Well, what we found was that as we put the gas system into action, that all of our contamination started going away in our groundwater wells. And so, and then what we found that was kind of new technology was that the gas actually pressurizes and mixes with the natural strata underneath the landfill and was causing these components to be found in groundwater. So, and at the end of the day, once we determined this technology, we ran the gas system, which it really wasn't a landfill leaking issue. It was a gas migration issue. Once we corrected that, the groundwater issues went away. We weren't seeing the contamination. And then of course the question I had for the EPA was, well, now that we know what's caused the problem, can we not be a Superfund site anymore? And they're like, no, we can't retract that. So we still had to head down that road, and the site still had to be managed and cleaned up per EPA Superfund. But my point in this is that we need to be cautious in making some of these rules and regulations. Scott noted on it earlier that, once we write something and we do it, it's very hard to come back. And so, and at Mosley Road, it very much specifically it was a technology, our technology had improved. We had a better understanding of what the environment does. And now it's a great tool for cleaning. So, but that's one of the things that we have to make sure that we're looking at. Best management practices, handling and disposal of the waste. So where are we at right now, with how we manage this? We don't have good testing, right? We maybe not have good sampling, criteria. A lot of the equipment that we use to sample right now, particularly at landfills, and in the past had Teflon coated materials in it, the clothing that we wear, so how do we test this? How do we create some best management practices? Well, in light of not having regulations, not understanding, the material, how it's going to be destroyed, how do we get rid of it once we do it? A lot of the industry has had to take the stance of, well, I'm not going to take it. Okay. Now, speaking as waste management, I had a conversation with our waste approvals directors for our non-hazardous industrial waste. Our process is we have a group of very, very smart people that understand the analytics and the chemistry of all kinds of waste products that potentially could come into the landfill, and we review those best management practice, right? We look at each one of them to make sure that it is not going to impact our facility moving forward. And so our stance, at least in our region, is that if it has any PFAS or that word is brought up, it's very unlikely that waste will be accepted into our landfill just for the purpose of, we just don't know. We don't know what the impact is of this on the backside. And I'm talking primarily the high concentration material, the foam, the stuff like that. These are the decisions that we're having to make based on this material. It impacts everybody. And I can promise you that the majority of landfill facilities that take non-haz waste, particularly in Oklahoma, they're aware of this chemical. And if this comes up that somebody wants to dispose of a container of PFAS, firefighting foam, it most likely will not go into that facility. And so then what are our other options? So we have to find other options. Incineration seems to be okay as long as we can, heat it up enough for a long enough time. Does it potentially go to a haz waste facility, and then what are the impacts of that? So that's kind of where our best management practice is we're taking, and a lot of the industry is we're just not taking it because we just don't know. There's not enough guidelines and regulations. So, which, I kind of understand where the DEQ is coming from in their writing of regulations, is that not everybody has good BMP. So at least we need to maybe potentially or possibly write rules and regulations that would make sure that people have BMPs to handle this kind of waste. So, you know, that in a roundabout way, I'm kind of answering everybody's questions, but I'm not. You know, how do we manage and dispose of this? And honestly, that's where we're at with this. You know, it's, you know, where do we go next? And it comes back, we all got to get involved. We all have to come up with new methods. We've got to come up with good disposal possibilities that are economical. You know, that's a big component of it. You know, one of the things that we're looking into, and I know the EPA is doing studies on it, is you know, we talk about disposal of this kind of material. You know, where are we going to go with this? You know, how are we going to dispose of it? You know, there's limited numbers of incinerators across the country, you know, that can potentially handle this. You know, how's that going to happen? And then the testing, you know, there's hardly anybody that can test for this material. So if we have all these regulations hit, you know, it's going to be a real quick learning curve, you know, on how we even get this material tested and potentially dispose of. Okay, go to the next slide. Okay, handling and disposal, health risks at recycling and landfill facilities. I know I've been talking a lot about landfills, but the EPA is currently researching the human effects of PFAS. Health effects have been seen, immune system issues, cancer, thyroid. I'm not an expert in this by any means, but you know, I think some of the topics later this afternoon will cover a little bit of this. But you know, so these are the things that we have to look at when we're developing BMPs, particularly for the safety of our employees and for our customers. You know, what's going to be the best way to manage it, to protect them and protect the environment. So primarily, and this is not only in our landfill facilities, but at our recycling facilities, where actually people, if you've ever seen a recycle line, and I don't go to the picture yet, but on my next slide, it actually shows a recycling facility. And if you can imagine, for the folks that haven't been to one, you're actually touching the materials, pulling it off, you know, it's dusty, things are getting broke down, you know, it's dusty in those facilities. So, you know, landfill the same way, you know, you've got a bulldozer, a compactor, you know, and it's pushing this material in. I don't know, for the folks that aren't from the state of Oklahoma, the wind blows a lot in the state of Oklahoma. So, you know, we're constantly breaking this material down to compact it and push it. So, you know, what are the health effects of my employees and potentially customers and our neighbors around our facilities? So with that in mind, you know, number one, you know, we make sure that not only for PFAS, but for other issues, you know, a lot of our facilities take asbestos, other kind of non-hazardous chemicals that, if they're broken down, could potentially be a breathing hazard. You know, having the proper equipment on the, you know, on the equipment to clean the air. You know, personal PPE. So if it's a skin or breathing issue, you know, we're all got very good at wearing masks these days, you know, wearing rubber gloves, same principle. You know, we want to keep that off of our skin and breathing in. Wash stations, you know, that would definitely be another PPE, particularly in a recycling facility. Make sure that there's adequate and sufficient cleaning stations for employees to make sure that when they're done with the shift, they're properly disposing of their PPE, cleaning, and maybe even, you know, providing, you know, uniforms for them. So that way that's getting cleaned and they're not taking that home with them. Increase cleaning of residue and residual dust. You know, it's one of the things, you know, you don't think about that much, but in a landfill dozer or even in a recycling plant, you know, you're breaking down material, it gets very dusty. Continually clean, because that residual dust could potentially be impacted to our employees and to customers. So for, you know, the handling and disposal of material, you know, that's going to be your number one BMP. And particularly when you're not sure of exactly what the health risks, these have got to be your minimum that you're doing. Go ahead and go to the next slide. Too far. Handling and disposal. Recycling and disposal facilities are not a source of PFAS. You know, the source is from the generators and even everyday waste that comes in. recent studies have found that the mass PFAS and leachate contributes to the POW is typically low. I already went through that. So, but these are the things, you know, and this is a great picture, you know, it shows employees, you know, long sleeve, masks on, eye protection, you know, gloves, you know, you've got to maintain at least a minimal type of protection, you know, for your employees and any customers that you may have. So go ahead and go to the next slide. All right, best management practices. I talked a little bit about it, but you know, the obvious thing that we have to do as a society and a community is we've got to reduce and eliminate the source of PFAS. It's already been done for the most part. I mean, we've reduced that kind of product being used in the United States. It's still being used in other countries for their ubiquitous type materials. And we still see it in some of, you know, there's still firefighting foam, you know, that's around that potentially could be used. You know, how do we dispose of that? But the key is we've got to reduce or eliminate this material, you know, from getting into the waste streams. Find other disposal options for industrial generators of PFAS waste. You know, that although I've concentrated in talking about, you know, landfills and recycling facilities, again, you know, industry generates a lot of this. This ends up in the POTWs and then eventually may come back as a sludge to the landfill. So it's something that us as a disposal facility, we want to try and manage and maintain. And so, and you know, the issues that could potentially come about that. At this time, you know, as I spoke earlier, landfills may be the best option for this right now, you know, and more study needs to be done to really understand this a little bit. But in the very limited information we have, it seems to be holding on to it a little bit more when you look at the chain, the circle of life, you know, on this stuff, which of course it never goes away, but it may be the place. But then what is the liability that we're putting on ourselves by doing this? You know, is it something that may cause an issue going to the POTW, and now this small town POTWs can't afford to treat their water? So these are things that we've got to look at. But right now, based on the regulations, if you've got proper BMPs, landfills may be our best option for now. So, all right, let's see. Talked about incineration, but go ahead and go to the next slide. So Captain Obvious, you know, sometimes things might seem really obvious, but in this case, I'm not sure, you know, may not be so obvious, but unclear until further EPA guidance. We have to get more guidance, and that has to be done by everybody being involved in the input and how this material is going to be managed, how it's going to be tested. Go ahead to the next part of it. Develop adequate personal protective program, you know, and these are the things that we can do right now. Is we have to, as an industry, not only a landfill industry, but businesses and government, is that we've got to make sure that we've got the proper protection in place of our employees and the environment. Develop BMP programs that will identify this, train your employees on this, on how to protect themselves. So go ahead. And number one, you know, and we've been very fortunate here in the state of Oklahoma that, and as I spoke at the beginning, the state, the DEQ, particularly with the regulated disposal industry, has been very, very helpful. They always listen to us. They're always working with us and hearing what we have to say and developing these rules and regulations. And so I would encourage everybody to pursue that. That's a very important piece of the process. We are in that phase right now. So if you're not involved in it, make sure that you get involved, because it will affect not only your business, but potentially impact, you know, everyday citizens in their health and environment and potential costs. And so go ahead. So questions. One of the things that I did, and I don't know how much time I've got left here, but I think I got a little bit of time. But I looked when everybody enrolled or got signed up for this class, they kind of had one little thought or question or note that why they were taking this class. So I kind of looked through some of those and picked up some of them, that I can answer, or maybe not answer. But one of the things that somebody asked is leachate pretreatment cost. That's a great question. I wish we knew that, but I think that's that's through my presentation. I think everybody understands. We don't know where that is. We don't know what the treatment potentially is, and how much that costs. That may be a technology that we still needed to develop and is being developed. Occupation handling and exposure. I'm gonna, for us right now, it's in BMPs. I know that that's being looked at. There's still some research that needs to be done on how that affects humans and in the long term. But we need to make sure we write these rules and determine our guidelines based on what the science is and what we're finding. Waste disposal, options. Seems like right now that because there's no guidelines, there are very few guidelines. We just have to enact BMPs. And sometimes, even though it's difficult, and as a business, we'd love to take everybody's waste. Sometimes you just can't take it because the impact and the liability that it causes us in the future could be great. So not only for the landfill industry, but also for human beings and people that may live in the regions. And leachate disposal, right now, I'll note again, the very limited amount of loading data that we have for PFAS waste coming into a landfill. Very small part of it is seen on the back end of it. And again, this is very limited data, so don't hang your hat on what I'm telling you. This is what we've seen in very small amounts. More research and information needs to be collected on that so we can come up with some good sound regulations and guidelines on how to dispose of this. So that's pretty much my presentation. If there's any questions, again, I thank Kima and OSU for having me here today. So appreciate it.
Great. Thanks so much, Pete. Aaliyah, anything in the room, any in-person questions for Pete?
Anyone? Hold on, let me just throw this on. Any questions? No? I think we're good here.
All right, I have a couple that have came in via the questions panel. Regarding general consumer waste in small communities, what are some of the best management practices that we can follow as consumers to help minimize impacts on health and, human health and the environment?
I think for the most part right now, because EPA has the use of PFAS material has been reduced overall in the United States. I think we're in a lot better place. The ubiquitous, there we go, the everyday type waste that we may see PFAS in is greatly reduced. And so for the everyday, day in and day out person, I think at least I feel that our best management practices, which is reduce the amount of waste that is actually, or reduce the amount of chemicals that are being used in the products that we may handle, is significantly less. So I think we've done a very good job of that. But moving forward, I think that the main thing for us to look is, using products that don't have those kind of chemicals in it. I know, like I said, industry's really done a good job of pulling those out of our products. But that's a tough one to really go over. Last thing you want to do is everybody, every time they get their Happy Meal, have to put on gloves and protect themselves. That's not what I'm saying at all. So we're in a lot better place than we were in the early 2000s. So I think we should feel confident that as a consumer, our products that we're handling are safe.
Great. Here's another one. Can you give the reference of landfill data, very small? You mentioned in your presentation about only 1% that comes back out of the back end.
Yeah, I'll have to pull. I don't have that with me, but I will. I do have the source where that came from, and I can get it to you, Amy, and we'll make sure everybody gets that.
Great. Here's another one. The mention that there has been a significant 70 to 89% reduction in PFAS in the bloodstream. If PFAS compounds bioaccumulate, is this 70 to 80% based on total population PFAS reduction versus prior population PFAS exposure? Is that correct?
That, again, that was out of a study out of, I believe it was Minnesota. I'll have to provide that because I don't know the exact details on that. So, but I can get that information where that study came from.
Great. There's another one that came in. EPA is looking for and having trouble finding industry partners for data collection and research. Are there any incentives that you can think of that would encourage participation?
Yeah, that's a great question. I think for industry in participating, I think you'll find that we are very willing to participate in the conversation and even look at it. But I think it's a matter of us feeling more comfortable with the testing process and what are we exactly looking at. I think that's there's a lot of unknowns with particularly the landfill industry and this topic. What is it that we're gonna look for? So I think if we can get the testing methods solid and they're giving us the information that we want, then I think you would see a lot more of the industry being willing to participate in these kind of studies. So, but there's a lot of unknown, and we want to do the right thing, and we want to make sure that the environment's protected, because for the long-term viability of our industry and for other industries, if we don't get it right, it's going to cause us a lot of issues in the future. So I'm not sure I quite answered that question, but yes, but I feel like there's still a little bit more to go before we get there.
Okay. And I know you touched a little bit on liability and such, but there was a question, would the parties that generated the PFAS waste and this waste was accepted by a landfill, would they be liable if the regulations change?
That's a big question. And in our history as a landfill industry that's regulated, and it's going to depend on the regulation, but typically, if once regulations change, then you're hooked, and a lot of times when they go down that road, there's no coming back. And so the liability, typically is on the generator, and so on. But that's one of the questions that we have to ask, that with this chemical, and we've got to collect more information on it. That's a great question that we don't really have a good answer to, but the liability typically is from the generator. It's cradle to grave.
All right, thanks so much, Pete. Any other questions? Again, we have just a few minutes left in the Q&A section of Pete's presentation. So if you have any further questions, please submit them in the questions panel. And if not, then we'll go ahead and let Pete wrap up his presentation. Thanks again, Pete, for a wonderful presentation.
Thank you.
All right, so now we have moved on to our lunch hour. We are going to take a little bit over an hour just to keep us on track according to the agenda. So we will resume at 12:35. We hope to see you all at that point and enjoy your lunch. Okay, everyone, this is your 5-minute warning. Sessions will resume in 5 minutes. Thank you. Okay, we have about 1 minute left, and just checking to make sure that we're all set in Tulsa.
And muted. Hi there.
Okay, ready when you guys are.
Okay. So welcome back, everybody. I hope we had great lunch time. So our next speaker is Andrew Palace. Andrew is a senior toxicologist at the Trihydro Corporation and a board certified toxicologist with over 20 years experience in industry, consulting, and government. He regularly reports projects involving damage to the environment and human health by chemical agents, including contaminants of emerging concerns such as PFAS. Andrew's other area of proficiency include high risk remediation and site closure, consumer product safety assessment, chemical exposure, and toxic chemical regulatory compliance. He is a member of various professional organizations, most recently the newly formed Barnes and Thorburn LLC PFAS Regulatory Coalition. So, welcome, Andrew.
Thank you, Kima. Much appreciated. Hopefully you can hear me well. And since Peter indicated previously that since I'm behind the glass partition, it's okay for me to take the mask off, and hopefully you can also hear me clearer. So again, thank you, Kima, and thank you, OSU, for hosting this event and allowing us to speak on PFAS and solid waste. Also would like to thank other speakers today and participants. So thank you all. And my section of today's workshop will be a little bit of a potpourri of history, background, chemistry, toxicology, and maybe looking at some of the current and future regulations, again, to put the context of what we're looking at. But before I do begin my presentation, I have a little music for you, just to listen in for a few minutes. And there's context to that. All right, that's good enough. So keep that music in mind, because you're probably wondering what's the link between the piece I've been playing you and PFAS. When you look in history closely, you find a link, and I'll disclose that to you next. Next slide, please. Next slide. One more. So as you suspect, some of the musical history and linkages between the classical piece I've played you and PFAS history. So let me explain how it's all connected. So if you think of PFAS, you really have to think about the atomic element, which is fluorine. So interestingly enough, fluorine and its compounds were really not that well used or understood in ancient history. One of the most common elements was the fluorite, and it was an ornamental ore of this nice purplish blue color shown in the insert. Further on in 1500s, again, they weren't sure what's happening here, but fluoride was also very useful in metallurgy. So it was helpful in terms of the allowing the smelted material to flow better. And that helps with metallurgy. Furthermore, an acid form of fluorine, fluoric acid, was used in 1700s to etch the glass. And it wasn't only up to relatively recently in 1880s that the fluorine as an element was isolated. And the little insert you see, it's the early report or paper comparing the the visual characteristics of air to your left, and then chlorine gas, and then fluorine is depicted with the darkest color to the right. Next slide, please. So here it is. The piece that I play for you was composed by Alexander Borodin. He was a Russian composer living 1800s or so. And he has a very, very, very rich repertoire with several operas, orchestral works, and other compositions. And to this day, his music is very well regarded and played quite a bit on your classical stations. In fact, other composers, more recent ones, like Debussy, for example, where they were modeling some of the work on Borodin's works. Next slide. In addition to being very, very accomplished classical music composer, he was also a very accomplished chemist, which is quite intriguing. And in fact, he worked in a laboratory of Emil Erlenmeyer. But if you remember your chemistry, there's that flask that has a very peculiar shape to it. And that was the mentor of Alexei Borodin. And Borodin's legacy was actually chemistry work with halocarbons. So he pioneered a lot of chemistry that allowed the bond between carbon and fluorine to be formed. So without Borodin's early contribution as a chemist, fluorochemistry would have taken a different turn, perhaps. So finally, it was about the same era that Jean Dumas was the first one to synthesize the organic form of fluorine compound, methyl fluoride. Next slide. And then the history really progressed quite a bit, as the earlier speakers indicated, and I think Annie Lou will be also mentioning it later, is that the true invention and commercial application of perfluorocarbons, again, genesis of the PFAS that we know today, occurred in 1930s and then 40s. So polytetrafluoroethylene, the polymer building block, was the true first perfluorocarbon as we know it. And again, if you look at the timeline, relatively recently, it was not long ago that this compound was investigated for its use in refrigeration. Next slide, please. Next slide. So real quickly, the question always you can ask yourself, what do they look like? Where PFAS, you can think of them as linear carbon chains, and these are represented by the gray spheres on the chain, but they can also be branched. There's isomers, so there could be a linear isomer of the same compound and a branch isomer. And then what's critical in the fully fluorinated compounds such as this with the functional group is the fact that all the hydrogens on these alkane chains were replaced with fluorines. So that goes back to what Dumas did and then Borodin's work. They were able to force that hydrogen off the carbon and replace the hydrogen with fluorine. What's also unique to PFAS in some ways is you have that chain structure or a different form and a functional group. In this case, you have a sulfur atom with 3 oxygen and 1 hydrogen. So that's the charge end of the molecule, whereas the other fluorinated carbon chain is non-charged. So as you can imagine, the chemistry is quite complex, but the particular compound I'm showing you is the PFAS, so perfluorooctane sulfonic acid. And this, what you consider, is one of the so-called legacy or longer chain PFAS compounds. Next slide. So that was the chemical or visual representation of the chemical. Now, other important terminology in the PFAS family is the fact that you can have non-polymers, individual compounds, or polymers where similar chain elements are grouped together in the polymers. And within the non-polymers further still, you can have those alkyl carbon chain partly fluorinated, and that's what the word is, and polyfluorinated. So this is the analogy right there. Next slide, please. Further still, and part of the reason why we have such issues with PFAS family, because they can range in size. You can have PFAS molecules that are longer or very short chain PFAS compounds. And typically the split in North America is anything longer than 8 carbons or has 8 carbons. It's a long chain PFAS. And anything less than that is a short chain. So what's happening today, and this is something that Mr. Scott Thompson was talking about, that even though the longer chain PFAS compounds have been phased out voluntarily for the past 15 years or so, the chemistry has been replaced with the shorter chain. So it's not like they necessarily have disappeared, there's been a replacement taking place, simply because the longer chain PFAS compounds tend to be environmentally more problematic. And I'll explain that later. Next slide, please. Right, and I think this is a very good graphic alerting you to the fact that even though we may know or identify some PFAS compounds, particularly the two, the PFOA and PFOS, most well studied, I think that there is a compilation out there that looks like nearly 10,000 PFAS compounds in addition to what we know right now. And I believe previous speakers were indicating that, yes, we can test for maybe a dozen, 2 dozen, probably 3 dozens of compounds identified. Well, there's others in this family that we do not understand or know. Next slide. So the reason why they have been so popular in a myriad of applications is because they are chemically, thermally, and biologically stable. So if you want to make a product with, or coat the product with PFAS, it will impart very useful qualities to it in terms of not only protecting the product itself, but also, for example, Scott Thompson mentioned mission critical application as in firefighting foams, that you want that fire to be taken out as quickly as possible without the foam being destroyed by itself by the chemistry or temperature of the fire. They also can be quite soluble, both in water and solvents, and they're not very volatile, which is good. They stay put. And then also others mentioned that they do have these very useful qualities that they can be both. They can repel water and also repel grease, which is really useful in consumer applications. Next slide, please. Next slide real quick. I'm not going to spend too much time on it because others have, and additional speakers will. But I find this graphic useful because it doesn't necessarily cover all uses, but these are the most common products that a consumer may encounter that has PFAS in it. So all types of stain-resistant treatments, non-stick cookware, waterproof fabrics, and so on. So you can see that there's 7 categories that if you had a situation when this was in solid waste, you might want to take a closer look at. Finally, on a non-stick cookware, just want to make a note that if it's, for example, the trade name Teflon, it's a polymer and it tends to be inert, chemically, biologically, and otherwise. It's only when it's broken down at very high temperature, for example, that those PFAS molecules will mobilize. But Teflon in its normal state should not be of concern to consumers. And I think there's a lot of misconceptions out there about Teflon. You need to get rid of your Teflon pans. That's not necessarily the case. Next slide. Okay, moving on. So I think in order to understand the environmental issues or global issues, it's also useful to understand the life cycle of PFAS in nature. So we need to understand the sources. For example, we have wastewater treatment plants that could be considered as point sources. They could also be industrial production. Of course, responding to hydrocarbon fires with PFAS containing AFFF products. And this graphic is actually quite useful in terms of, because it looks at it holistically. So through these point sources, we have releases into surface waters, groundwater. There's also been instances where PFAS were found in food, milk, for example. So it's really truly a global issue. It's a comprehensive issue, and I don't think any part of the environment would be considered as free from PFAS because they travel so well through air, through water, and other media. Next slide, please. Right. Okay. So one may ask the question, okay, Andrew, what are we looking at? Where is it at, right? So this was actually a very useful paper recently published this year, or in the spring, that it was essentially a problem formulation paper where they did a comprehensive literature research and looked for frequencies of reporting. Where do we see PFAS in terms of the exposure media pathways? So you can see the vast majority of the instances of reporting of PFAS presence was in food. So the food exposure pathway, it's 40%. The next is water. So that's what they reported. And then other pieces of the pie are much smaller, but you can see that soil and wastewater also were reported as having PFAS in them. Next slide. Still from the same paper, but a little bit different presentation of their literature search results is in terms of the exposure categories and with the reported frequency in the histograms. So expectedly knowing how PFAS are present in the environment, indeed environmental media accounted for 58% of the reports that they categorized. And then specialty products were next. So this is where the special treatment occurred to any of the products to impart those unique properties. And then I think probably most of importance to demolition projects is the harm products, articles, buildings, materials with a lower amount. Anyway, again, very useful research. I'm looking forward to perhaps the next series in their paper when they dive deeper into some of these exposure pathways. Next slide, please. And I believe that also previous speakers indicated that we have seen reductions essentially in exposures over the years. So this is a little collage of general environmental trends. And we're looking at the longer chain, the legacy PFAS compounds. And on the left series of charts, you can see that's a heat map going back to 1980s through 2000s and 2020. And you can see that in 2000, there's a significant spike or increase in releases into the Atlantic Ocean from the East Coast of the United States. But since the voluntary phase out about the same time, you see that the data indicate that 2020s. And then knowing that some of these compounds do bioaccumulate in biota, we also see similar trends in reduction in bioaccumulation, for example, for squid. That's the middle panel. And then finally, some of the indications of levels in human blood of PFAS, you can also see a trend over the time, at least in this study. So in human population. So there is some actual empirical evidence to show that the phase out, the voluntary phase out in America of the long chain PFAS compounds resulted in reductions in human blood of PFAS. Next slide. Okay, so real quickly, of course, the regulations, the limits, the health advisories, one would think that they have a basis in terms of protecting human health and environment. As Peter mentioned, they're ubiquitous, so they're virtually everywhere, in everything, and everyone, and this is true. Also, they have those persistent bioaccumulative properties, particularly the longer chain one. And there's associations, indeed. There's empirical associations between high level of exposure and effects, and those are listed there. Next slide. So then, as a toxicologist, or risk assessor, or risk manager, you would like to determine, okay, what is the conclusion? We're detecting them. We're detecting them with some frequency in various exposure media or products. What is the risk, right? What is the risk to human health? So I think that we have enough tools at our disposal, although some are limited, for example, the effects data. Nevertheless, I think we can come up as risk assessors with some reasonable estimates of what the actual risk may be. At least for some of the more studied two compounds, the PFAS, the sulfonate, and PFOA carboxylate, and then perhaps extrapolate using various approaches to what some of the other PFAS compound risk signatures might be. So definitely, this is very early in the process, but nevertheless, we don't necessarily have to start from the beginning. There is enough for us to draw some human health risk conclusions. Next slide, please. Right. As I showed you before, that iceberg, what do we do about the PFAS that are there, but we can't see them, but we know they're there. So how do we know they're there? Well, there was this one interesting study in Massachusetts that looked at not only the two critical PFOA and PFOS compounds for which EPA has health advisories on in the United States, but also they did total extrapolar organic fluorine. So it's a technique that doesn't look necessarily for specific compounds, but all compounds that have that carbon fluorine organic linkages. As you can see by those histograms, by 2016, the proportion of the total PFAS in that water sample was indeed exceeded by those that we don't know. So keep that in mind as the EPA or state agencies look at for additional PFAS compounds. So they're out there. Next slide. Right, human health. So what about wildlife? How are they faring? Well, I think that in terms of the general statements, the biological systems are fairly unaffected by these PFAS compounds. So there's no overt mortalities, toxicities that we see in the environment. Now, we are still studying it, so we can't tell for sure, especially those chronic effects at very low levels. So we don't know the full picture quite yet. Next slide, please. So I'm going to skip this slide in the interest of moving on because my next speaker will be just after me. So please go ahead. All right, moving on, next slide. And this is what this is the analogy that Scott Thompson earlier this morning was indicating, that the level of resolution, the analytical resolution that we need to look at is essentially one drop in 20 Olympic-sized swimming pools. So that's 1 part per trillion, just to give you a little concept of where we are. Next slide. Okay. Right. So this slide again is speaking to the fact that there's multiple methods out there. Most of them are drinking water, i.e. clean water that does not have any interfering compounds in it, and where the detection limits can be met rather than what's actually possible in terms of detecting the PFAS compounds. And also in the box you see approximately how many analytes each method has. So, so you can see that we're still a long ways off to fully understanding a good number of them. Next slide. Okay, so let's look at the future. This graphic summarizes the regulatory playing field. And mind you, this is only for the federal government, so essentially US EPA. And each column represents either current regulation that encompasses explicitly PFAS, then the future PFAS actions that Peter was referring to, some of them. And then there's really no clarity as to what the federal is going to do in terms of the other rules. But under the regulated column, PFAS already are included with TSCA, Toxic Substances Control Act, as they are in the EPCRA, particularly under toxic release inventory reporting. So these are included. There's also 2 others that are a little minor, relatively minor in terms of the environmental aspects of it. And I think the biggest EPA actions to look for is the release of the drinking water standards under the Safe Drinking Water Act. Another aspect to look for is regulations under the Clean Water Act, and that could include the NPDES permitting. PFAS are not currently included in the permits, but according to some of the work groups that EPA is holding, that I think the recommendation is, and they may be, if there's enough reason to include PFAS in your permit. So that could be coming. And of course, the designation as hazardous under Superfund Circular or RCRA. And I think RCRA captures some of the waste management aspects. Next slide, please. So the next series of slides essentially verbalize some of the key regulations or actions that EPA will be taking. I'm not going to spend too much time on it other than just to alert you to the fact that EPA does have the health advisories. They had them for a while for PFAS, 70 parts per trillion. But also interim recommendations for groundwater that the EPA made is that 40 parts per trillion is claimed as the risk-based screening level for PFAS and PFOA. So you can see that the bar is getting a little bit lower in terms of the CERCLA regulations. Okay. All right, next slide, please. Just this slide essentially captures some of the difficulties in terms of managing PFAS at contaminated sites. Since we don't have a lot of clear guidance out there, everything is really done on do and learn basis. There's really nothing preset. So of course, some of the difficult aspects are that the levels that we have to detect or attempt to detect at very low levels. And it's a complex mixture, right? You're not just looking for one or two compounds. You're trying to assess the presence and extent of as many potentially PFAS as you can. And because these levels that you're detecting are so low, you have to be fairly careful about contamination. And this is also something that Scott Thompson brought up this morning. And then analytical methods. These contaminated sites, they have impacted media, which essentially may not always be very clear or easy to work with, analytically speaking. In terms of the remediation methodology, conventional treatments are really not well suited. Currently, the standard is granulated activated carbon and ion exchange resins. This is also reflected by some of the EPA guidance recently. And then, of course, the ultimate goal is to destroy PFAS, not to move it from one place to the next. It's really destroyed wholly. Incineration was talked about, but there's other methods as well. And so is the disposal well injection. Next slide, please. Okay. So again, this slide is indicating that there's a lot of research actually going on right now, and federal agency are funding supporting this. And all of them either attempt to break that carbon-fluorine bond, or maybe reduce the amount of PFAS contaminated volume of water by something like employing nanofiltration, for example. There's a lot of movement in that. So microfiltration, reverse osmosis, all those membrane methods that would be able to retain the PFAS on one side and allow the clear water to pass through. Next slide. Okay, so then also as a risk assessor, but also risk manager, looking ahead, right? Regulation is one thing. Remediation technology is the next. You know, what can I use in my toolbox? But also, we all have to be responsible for liberal strategic thinking. And I think one of them is, you know, look at your sites, look at your locations, look at your properties to see if there were not only on-site, but also off-site releases around you, because PFAS are very mobile. that can travel extended distances with groundwater. And the whole liability issues is, what could I be sued for? And finally, occupational exposure. I think Don will be talking about that next. Next slide. All right, so in summary, there's no doubt that PFAS as a group of compounds is of increased environmental profile and thereby of increased potential in actual regulations. We're all exposed. It's an environment. I think there's no way to put that genie back in the bottle. It has to be dealt with. Now, in reference to today's workshop, is they are present in waste streams. Now, we can't necessarily measure them very well, or there's no resources to assess what's the concentration of PFAS in this waste, but it could be possible. And then finally, I think once the hazardous designation is introduced under the CERCLA and RCRA, I think we'll see a lot more legislation, regulation at the federal and certainly at the state level. So with this, that's all I have, and thank you for your attention. Much appreciated. And Amy, I believe that for Q&As, we'll have a combined session after the next speaker delivers his presentation. So thank you.
Thank you, Andrew.
Thank you.
Okay, thank you, Andrew. So our next speaker is also from the Trihydro Corporation. His name is Don Pugh. He's the new senior scientist at Trihydro Corporation. While Don is new to Trihydro, he is not new to the environmental field. Before coming to Trihydro, he worked 24 years as an environmental engineer with a senior US Airlines. Don is a senior scientist and ensures compliance with federal and state regulations. Don completed his Master of Science in Environmental Science at Oklahoma State University, go Bucks. He also has a bachelor's degree in environmental management from Northeastern State University. Don is also a certified hazardous material manager. So you're very welcome, Don.
Thank you. Go Pokes.
Go Bucks.
We have a poke fest here. All right. Yeah, let me take the mask off. Taking the mask off, I was sitting there thinking about things that Scott had said about the clothing for sampling and how that's needs to be redesigned. Let me turn this off. I have to find the switch. Okay, I think I got it.
Okay.
Yeah, so I was thinking about this mask and I hope it doesn't have PFAS on the inside. That would be interesting. I think there's going to be a whole new industry out there of garment manufacturing that will carry a no PFAS label, just like no BPA kind of containers and things like that. So I look for that in the future. And so I was all in with Scott when he talked about digging up North America. I was ready to go out and buy a company of backhoes and get involved in the business. And then Peter came along and reminded me when I was growing up, I lived in a small town in Kansas, and they call it the city dump. It didn't even have the fancy name of landfill. And so sort of like Perrier water versus just regular water. And so, so that's, I'm very intrigued by all the speakers ahead of me, and I appreciate all the information. I wanted to thank Kima for the nice introduction, and OSU for hosting this presentation, this workshop. Also, Leah for the local tech support, and Amy back in Wyoming for tech support and slide presentation today. So I've worked in the airline industry most of my life, either as a mechanic or in the military or at American Airlines. After I got my degree, I moved in environmental, but I saw what was happening in industry as a direct onlooker of how chemicals were used in the shop and how they were disposed of, and knew there had to be a better way. Than a wrecker came along in my degree plan, and so that is basically how I'm going to be framing occupational exposure and safe worker handling today of chemicals from a occupational facility background. And so, next slide, please. Oh, next slide. So PFAS are broad groups of chemicals. They're unique. They have unique properties, as Andrew pointed out, with the neutral tail and a very active end, one end water loving, and so we see where they're very unique, but the properties are enjoyed by many industries. They are very much appreciative of those properties in making their life a little easier. And we're going to look at just one of those industries in just a moment. As we looked earlier at other presentations, it's everywhere. PFAS has been found in solid waste, has been found in soil, groundwater, leachates, wastewater, and the list goes on and on and on of where PFAS has been found. Next slide, please. So this wheel is not proportional if you're taking into account Andrew's slide of proportionality with the non-stick cookware. The segments are equivalent in size, but we all know somebody in the company that you work for may be a volunteer firefighter, may purchase their breakfast meal on the way to work in a clamshell or in another type of container from fast food. They may even work part-time doing photography work, maybe weddings, and they develop their own film in a dark room in their house, and or they, for a living, they paint different products with a paint that's mandated by a regulatory agency, and it has Teflon for chafing purposes. And so you can't get away from it. It's in the paint. So the best you can do is to engineer it out, administrative control it out, and lastly, PPE it out. And so we're going to look at some of that today on waste handling. So next slide, please. So the framework, as I mentioned, is the EPA regulations, primarily Resource Conservation and Recovery Act, on how they relate to solid waste, occupational exposure, PFAS handling, disposal, and we got one slide dedicated to CERCLA and in relation to due diligence and phase one. Next slide, please. So there's 4 regulatory goals for RCRA. protecting the environment and human health, conserving energy and natural resources, reducing or eliminating the amount of waste generated, ensuring the waste are managed in an environmentally sound manner. I would like more of bullet 3 to occur to the elimination or extreme reduction in the hazardous chemicals used in occupations. I see them as still way high, and we can do better than that as far as developing new chemicals that are safer for the environment and the health of the employee. Next slide, please. The two main disposal programs in RECA are Subtitle C, hazardous waste, often referred to as regulated waste. Subtitle D, non-hazardous waste, often referred to as non-regulated waste. And RECRA builds a framework for handling all waste. If you funnel it from the top to bottom, going through their matrix, and we're going to kind of look at that matrix here in just a moment. It's a flow chart of different characteristics and listings, and allows you to get to the bottom of where that waste needs to go. The goal of waste determination is to get PFAS into the correct disposal program, whether it be C or D, needs to go somewhere. But as Scott mentioned and Peter mentioned earlier, when you get it into the correct framework of disposal, then you can run into some problems, future tense, with the heightened awareness of PFAS, because you have all sorts of things that impact the end of life of each one of these programs, mainly land disposal restrictions. When you do your profile for your waste, your land disposal restrictions are one of the things that you look at. Can I apply this to the land after treatment or not? And if it's a not, then where do I take the waste? And so those options become narrowed if they cannot be land applied. Next slide, please. So I developed 3 bullet points that actually frame the outline of this presentation, and they are as follows. PFAS containing materials have become essential for modern life. That's based on everybody that's spoken today. We can see the products they're in. They're literally ubiquitous in everything, whether it be on the container, whether it be in the clothing that we wear, whether it be in the chemicals we use. It's something that it's hard to get away with from in certain industries. And the second one is workers can be exposed at PFAS at home and at work. So usually whenever the assessment at work on worker exposure, you're wondering, okay, did they get this at work or did they get this at home? Well, PFAS is it kind of bridges that, and you just get it in life in general. PFAS is containing materials become waste too. At some point, everything goes from product to waste. Hence, you have flammable cabinets in the workplace for product, and you have satellite accumulation areas and central accumulation areas in waste disposal. And in that process of somewhere between product and waste, you'll need to decide that it's no longer product and needs to be disposed of, and RECRA forms that framework for doing so. Next slide, please. So modern life as we know it today, truly human, as was mentioned in earlier discussions and conversations, was that we are relying on the consumer to tell us how we want things packaged, whether it be glass, plastic, if we want 6 grouped together, if we want one individual. how we want it packaged. And so in the medical industry, as well as other industries, they rely on certain characteristics of the materials that they use in the form of product. And so biocompatibility, long-lived materials, which we hate on disposal, long-lived materials, chemical inertness, durability. These are all characteristics that the health industry embraces as being a positive when they look at materials. They don't want something breaking down in the surgery room because of inferior product. They want something that's going to be long-lived. And so they're looking for these 4 characteristics, which are on the opposite end of the spectrum for disposal and getting rid of that product at the end of work life of that product. Next slide, please. So in the surgery area, in medical treatment, we have some of the products that are dedicated to the environment, to the surgery room, to the doctor's medical examining room, and then we have some that are related to patient, all of them containing PFAS. We want contamination resistant gowns, surgical gowns and gloves and things like that. We want wall and floor coverings that are very durable because when one patient leaves, it gets scrubbed down and the next patient comes into the same environment, and they want to use aggressive cleaning techniques to make that happen. So we need some durable chemicals that have made products for this environment. So implantable medical devices like grafts and stents and meshes, heart patches, catheter tubes and guide wires, sterile container filters, needle retrieving systems, tracheostomies, and inhaler canister coatings. This is just a small list of things that the medical community uses that have PFAS within them. Next slide, please. Moving on to more of a industrial environment, how do you know if you have a potential for occupational exposure? The best thing to do is start at the beginning, which is a good place to start, reviewing current SDS. We've had changes in the SDS over the last few years in the presentation and the look of the harmonized version. And so we're just now getting used to it. And so what we should be seeing is that PFAS is going to be emphasized on the SDS. In fact, the next bullet talks about how do you know if you have the opportunity to be exposed. You take that SDS and then you look at it in relation to the TRI reporting list, and they've got over 170 chemicals on there. And so it's very easily to take that CAS number and match it up and to see if one of your products happens to have PFAS in it. The interesting thing about SDSs in the industry, they are regulated under OSHA, but the fact is it's a communication device, not only to the worker, but to the company. And so what generally happens, the manufacturer is only obligated to communicate through certain means, and usually they choose the SDS to do that. And they normally slap the new SDS on the first shipment to a company. There's no requirement for every shipment to have an SDS on it, but when you change the chemistry of a chemical, it changes in nature, you're required to communicate that with the company, and then that trickles down to training at the company. But what happens is if you have a large company that has a warehouse, they rip those things off and they go right in the trash, and you don't even know that you had a change in your chemistry. So you have to have a conversation with that supply line, that supply chain in your company to be on the lookout. Also, all SDSs are supposed to be current within 3 years. And so you should be seeing some new dates on them. The other part of this is that they're very, once you study an SDS and look for the storage and handling and the health of the type of PP, to where they're very explicit on all of those, and they are what the manufacturer's recommendations are, and the way that procedures are written is you follow manufacturer's recommendations, and one of them is the SDS. The other way to know if you've been occupationally exposed is knowledge of process. Do you manufacture, process, handle, use, consume, whatever it is, a product that is PFAS or PFAS containing materials? Knowledge of process. You got to know your knowledge of how your product starts out from raw ingredients to the end of the shipment of your product, whether it be you're a paint manufacturer, whether you're a PFAS, AFFF manufacturer, maybe you're just a repair facilities like an airline, and you've got these products coming in. Most products coming in are not single sole source ingredient products, because we're not manufacturing anything there, we're repairing. And so when you get the chemical, it's a multi ingredient chemical. It may have 99% water and 1% PFAS. Maybe it's ingredient, but you've got 2 ingredients there. And so when you look at your SDS, you want to know your process along with your safety data sheet. If it's a yes, conduct a process hazard analysis of your facility, looking from start to end for those subtle ways that employees can be exposed to the product unknowingly. Then next, once you discover those, do a job hazard analysis, adding PFAS to the checklist. Okay, now we're looking for something else. I was checking for this. Now I need to check for this and do that. If it's a no, maybe the previous owner of your facility is not brand new to you, but it's new to you, but it belonged to somebody else previously. Maybe they used PFAS or a PFAS containing material on the property before you arrived, and maybe they didn't clean it up so well. But even if you did a phase 1 assessment, site assessment, chances are past phase 1s were not looking for PFAS as a chemical of concern. And so that gives us some problems going forward. Next slide, please. Exposure. Exposure happens a lot of different ways, a lot of different places. And I put in here is a when. When can exposure happen? And I put in some bullet points, assuming you're a industrial manufacturing facility, you can ingest or inhale contaminated soil. If you do a lot of construction on your property, you're adding onto your building. Dust from dust collectors. Dust collectors are not always operating to their highest efficiency, and you have dust settling on horizontal surfaces from dust collectors that are not working very well. When involved in the manufacturing, processing, and handling of the PFAS containing materials, there is a certain amount of human handling, and not everything is automated. Cleanup of small spills and splashes. You are working at a workbench using a chemical and you knock a quart of it off your workbench. You have to clean it up. Are you wearing the right PPE to clean it up? You have small spills and splashes. When storing PFAS in warehouses, sometimes you have forklifts which do not always go exactly where you want them to go, and they may puncture a container. End of shift cleanup, as I mentioned, dust and spills and things like that. As you do your cleanup, are you using what are you using for your cleanup? Are you using a broom, using a mop, or using a vacuum to clean up your PFAS contaminated floor or workbench. During PFAS material spill response, if you are a sizable company, you're used to responding to spills in your facility that are large, 55-gallon drums, no problem for a spill response company within your facility that can be readied in the moment for that. But if you add in PFAS, oh, by the way, one of the ingredients is PFAS. They're right now not prepared to do that, which means that future HAZWOPER training will need to include this as a topic, PFAS. When using PFAS containing materials at work as a product, I mentioned the paint, anti-chafing, good for flaps and moving parts. But also firefighters, especially the ones that are weekend warrior or volunteer firefighters. They don't always have all the PPE that they need or the training as a big company in a major city. Next slide, please. How may it occur? Well, it's the usual 4. These are the same entry points as any other chemical. Eyes, skin, ingest them through swallowing, inhaling them. The only other one I didn't put on here, puncture, which is usually you've scraped up against something, but typically not in this particular environment of exposure. But I do recommend that you get the latest SDS. Remember this year, 2000 is the reporting year for those 170 PFAS ingredients on the TRI. And so it's always good to make sure you have the most current SDS to be able to do that. Also, when you're requesting your SDS, make sure you get a tech data sheet. It really frames the product for what it's was used for. And sometimes there's a lot of good chemistry data on a tech data sheet as well. And so I encourage having both in your file and maintaining those, having the newest on always up to 3 years new. Next slide, please. On handling, for concentrated chemicals, this one happens to be off of the AFFF, but anytime you use a concentrated chemical, and I've looked at some of the others and matched them up with the AFFF, which is very concentrated on its ingredients, and so avoid contact with skin and eyes. Use local exhaust and dilution ventilation. You have some PEL limits next to your ingredients on your SDS that gives you your permissible exposure limits or threshold value limits, so you'll know where that threshold is. And you want to make sure that you use the enough air changes to meet that exposure control. Use tight sealing goggles, wear protective gloves, protective clothing. If exposure guideline limits cannot be controlled, then you'll want to wear a NIOSH or MSHA approved respiratory protection. Always moving upward if concentration includes more concentration. Firefighters, spill response guys, always use a positive pressure supplied air respirator for high concentrations. And always chemicals are stored in a cool, dry, well ventilated area away from incompatible materials. Those incompatible materials are listed on your SDS, so when you store your chemicals in either your warehouse or in your shop, make sure that they are not near those incompatible materials, and for good management. And always follow the guidance for your specific chemical. Next slide, please. They can become waste too. Well, waste is something that we've been talking about. Disposal, until a product becomes waste. As long as you're using it, it's a product. Even a tank with chemical in it, as long as that tank is being used, then it's product. And so, but with waste, once you determine it's waste, then you have to follow some guidelines, and RCRA frames those waste disposal regulatory patterns of disposal, which are very effective. And but when they were designed, they were designed for the conventional chemicals we all know today, not PFAS. And so that adds another element of the regulations not being current enough to handle that waste code that is inevitable of coming for a PFAS related hazardous waste, whether they classify it in the list under toxics or where they stick it. Eventually, we're going to see a way in RCRA that will allow those chemicals that are concentrated, maybe sole ingredient chemicals, PFAS sole ingredient, to be sent away as a hazardous waste. But currently, it's not there yet. So once you go through the waste determination process, the first thing on the list is always, is it a solid waste? And you got to answer that question, because that everything hinges on that. If it's not a solid waste, then you don't have a case here. So, but it meets the regulatory definition. Then you look for exclusions. Then you look for your lists, your process list, your sole ingredient list, your off-spec list. Then you look for characteristics. Does it have one of the characteristics? One of the PFAS SDSs I looked at is married with a flammable. So the actual ingredient will carry a flash point. Is that flash point in the range of ignitability, which is one of your characteristics? Is it a mixture of solid and listed waste? So did they maximize their haz waste by taking a non-haz and mixing it with a hazardous product? And lastly, is it derived from a hazardous waste? Next slide, please. So I wanted to spend a little bit of time, since everything hinges on a solid waste. If it's not a solid waste, it can't be a hazardous waste. So the term solid waste means garbage, refuge, sludge from a waste treatment plant, water supply plant, air pollution control facility, discarded materials, including solid, liquid, semi-solid, contained gaseous material. And this particular definition was taken from U.S. Code Title 42. There are other sources of the definition, but want to be clear here that when it comes to domestic trash and things, you get your exemption out of here. And we're going to see that in the next flow chart. So next slide, please. So you go through a chart similar to this. It's on the EPA website under solid waste identification. And so, is the material a solid waste? Well, that's kind of obvious. We just got through that in the last question under definition. We determined that all of these items that we talked about today, candy wrappers, trash from home, trash from work, just regular garbage, is a solid waste, but it falls out in an exclusion under the flow chart in the blue square, where you've got an exclusion from this, in the fact that it's domestic trash excluded from the definition to go on. So you're no longer subject to subtitle C. So it moves into subtitle D. And so you're looking at it now from a non-haz standpoint. How can I take care of this from a non-haz standpoint? But let's say again, you have a PFAS that is in a paint with a solvent and a flash point, and you go through and you say, well, no, it's not excluded, then it's is the waste listed or characteristic? Does it have the characteristic for ignitability? Or is it toxic? Sometimes PFAS is in a corrosive combination with other chemicals. And so you see that it could be a corrosive or a toxic. And so if you say yes, then is it delisted? Not very many items are delisted on the delist list. So then you would say, no, it's not delisted. Then you will see that the waste is subject to subpart C. And so your paint example would go to disposal, not for PFAS currently. It would go because of the characteristics of the product, the toxicity or the flammability or one of those. It's either on a list and would go there for that reason. The next slide, please. So chemicals create presumption that everything's hazardous. If it's in a chemical form, then it's usually hazardous. But after going through the waste determination, the one for the AFFF and others are currently not regulated for transportation. They're not regulated on disposal, and so they would be. We've seen that they're solid waste, but they're excluded and become a non-regulated waste. And so I spoke with the TSD and they said, yes, you can send your non-regulated waste to a treatment storage disposal facility. Obviously, it's a lot more expensive because then you are taking advantage of all their strict requirements of running one. But if approved into the municipal landfill, and this goes with a caveat here that my dealing with landfills, your plain old trash, even though they're candy wrappers that may have PFAS, your lunch, those are all trash and they go into the landfill just like at home. But in the when you're at work, you have a category called special waste. So let's say you're cleaning out your cooling towers or you got a sludge pit or something like that. You have to profile that waste and send that profile to be approved ahead of time. And so as Peter mentioned, that if, as a best management practice, they may say, it's got PFAS, we don't want to do that anymore. So now your sludge, which was you were profiling to go to their landfill, no longer can go to their landfill, so you're scrambling for a location for it. And so that is one of the train wrecks we talked about earlier, about this train coming for us and not knowing what the end of the life cycle presents for us on disposal. Next, employ as many sustainable practices for waste minimization as you can. Try to go zero waste to landfill if you can make it there. Reduce, reuse, repurpose, recycle, recover, upcycle. There's many names given to it. The difference between recycle and upcycle. Recycling has an element of destruction. You've got your aluminum can, you have to smelt it down, you have to extract your aluminum out of it to recycle that aluminum can. Upcycle means you've taken an aluminum can and you made a flower vase out of it. You didn't do anything different. There's a certain amount of creativity to upcycling, and it's very popular today. And of course, all of this may change whenever they start looking at disposal of PFAS waste. And I've got one last slide. If you'll go to the next one, please. Deals with due diligence. and the purchase and divestiture of real estate, primarily on the industrial side of the fence, and deals with acquiring property for your business. Because of the fact that a lot of times you don't know what occurred somewhere before you moved in, you want to do some sort of due diligence. So you pay companies to do this for you. All of the consulting companies offer this service of phase one, and they will come and they'll do some background checks to look for all of the owners, property owners, how it was used. Was there a gas station there? And they will basically do this phase one, and it's the gold standard for transactions. If you got the seal of approval on this, you were good to go. You knew that a skeleton wasn't going to come out of the closet that you'd be liable for. Well, with the CERCLA in the PFAS action plan, which I encourage you, just like was mentioned earlier, please get it out, read it. It's their playbook of where they want to go. And so if it is deemed under CERCLA as a hazardous substance, then since CERCLA has no time limit on discovery of things, do we open back up those phase ones again that we've already done, looking for that? And what if we find PFAS in the soil or groundwater? What then? And so chances are when future phase ones are done, you're going to have PFAS being one of the lookouts. So again, this will all change with future regulation. This is the last slide. If you want to move to the next slide, we have the question slide. And so both Andrew and I are both open to answering questions. Obviously, I would do very poorly with toxicology. I told him earlier that, yes, I'll tell everybody your arm will fall off if you touch it. And so not a very good RECRA answer for toxicology question. But if you have the question, then please assign it to Andrew or myself. Whoop, got one.
First, Don, you mentioned AFFF firefighters situation, curiosity question. Do you foresee maybe like class action rulings against these chemicals for the firefighting industry, just like the asbestos and pesticide industry has gone through recently?
Yes, I expect class action lawsuits. I recently took a HAZWOP refresher, and the guy didn't want to talk about it. He does classes on a response, and he does a lot of different classes, but he also works in the firefighter industry as a volunteer firefighter. Just last year, he was fighting cancer, and he wouldn't talk about it because he said that right now, lawyers are looking at his complaint of believing that the AFFF helped that cancer develop. And so I do look for it to come out in the future.
I have another question, possibly for Andrew. Your iceberg slide got me to thinking of 10,000, essentially unknown PFAS. Is PFAS found in nature, or are they all man-made? If they are man-made, why don't we know all of them?
I think Andrew's going to come up here, so it'll be on mic. Because we want to, mine was, do we see class action lawsuits in AAA cases? And I said yes in the future. But Andrew's going to answer the question, is it found in nature? So I'm going to take the mic off. That way we can share the mic. Okay, we on the break?
Yeah, we are right up to the time. We might have to save some questions and answer. We might have to save some questions and answers, yeah, for the roundtable.
Well, at least let me answer the question that was posed, and let's hold the other questions. All right. Just to repeat the question for maybe people on the online that couldn't hear back of the room, but the question was posed looking at the analogy of the iceberg, that we know very few of the PFAS compounds or understand them. And the first part of the question was, if I remember correctly, is are they found in nature? And the answer is no. We don't see that carbon fluorine bond too often. Of course, there's some aspects of it, but those PFAS compounds, the way they exist today, they're created by our technology. And then the second, if they're all created by our chemistry, good question. Why don't we all them know? Well, I think the issue here is that when synthesis occurs, it's not intentional. I think there's a vat, if that analogy works, of various processes that creates not a single unique distilled PFAS compounds. You end up with very, very complex and known mixture. And I think there's other analogies out there. Some of the early insecticides, like toxaphene, for example, it didn't end up with just one compound that was active. The chemistry was such that you ended up with just about everything. And the problem is you didn't know exactly chemically what was in that soup of PFAS that you just created, if that's the answer. Thank you. So with this, I'll relinquish the floor to our break, our next speaker.
Yeah, we'll go ahead and do we'll do a 5-minute break. Meet back at, let's say 2:05.
Okay, we have about 2 minutes left in the break, just 2 minutes left. All right, I think we're ready to begin our last presentation. Kima, would you like to go ahead and introduce Annie Lou for us?
Amy, can you hear me?
I can, thank you.
Okay, good. So our last speaker for today is from Clean Harbors. Her name is Anilu DeWitt. Anilu is the National Technical and Sales Lead for the Emerging Contaminants and Water Treatment Program for the Clean Harbors Environmental Service Group. She brings her 25 years of experience in the environmental laboratory and remediation field to Clean Harbors to assist clients in interpreting their analytical results to evaluate their options for treatment, utilizing varied medias and pre-treatment equipment to achieve project objectives. Having worked as a GC and MS, and also most recently as a LC-MS chemist for PFAS compound, she believes in the importance of evaluating the project as a whole, from suggesting the most valuable testing methods at the beginning of the project that helps determine the best treatment, trends, and medias for complex waste streams to informing clients on their options to final disposition of their spent media. Anilu holds a BS in chemistry geology from Bridgewater State University. So, Anilu.
Thank you. So, first of all, thank you so much, Kima, OSU, and Trihydro. I apologize. I want to make sure that, are you going to be advancing the slides or am I? Because I'm not seeing my.
I'll advance them for you. So if you
Well,
just say next
thank
slide.
you. Yeah,
Yeah.
so next slide. This is just to show Clean Harbors and how we're across the whole US, Canada, and Alaska. And And so we have a wide assortment of people that can help with the service part of our treatment program and disposal. Just a brief introduction if you never heard of Clean Harbors and you thought it maybe was a smaller company. The next slide. I work for the Water and Remediation Group, so it's a full range of specialized solutions for treatment of air, water, and soil. Not only do we treat emerging contaminants, but your general contaminants from oil and gas industry, PCBs, pesticides, metals, so a wide variety. Next slide. You know, this is just talking about how we do this. A lot of our work is emergency response, from 10 GPM all the way up to 10,000 gallons per minute, depending upon the project and where it is. The next slide. The key concepts that we're going to talk about today is, we were talking about, so why don't we, this question, the last question, so why don't we know what all the compounds are? Well, PFAS chemistry is proprietary chemistry, and what that means for treatment, informing customers of current options so that they can make the most informed decisions, selective identification and non-selective removal, conservative skid approach, and then source treatment benefits. Next slide. PFAS chemistry. PFAS chemistry originated from a failed refrigerant cooling experiment. I want to make that point kind of clear here, because they were actually trying to make a refrigerant similar to like a Freon product. And so it didn't actually happen. So it didn't turn out to be a gas. It turned out to be a liquid material, okay? And I just want people to keep that in mind, just to think about partially destroying PFAS. So just something to keep in the back of your mind for today's presentation. It was discovered by accident in 1938, and it was described as the slipperiest material in existence. So obviously the commercial possibilities were and are endless. The chemistry is complicated, and it's not well understood outside of the companies that produce these chemicals. Small and large changes in chemical structure can be made and patented. So this is kind of important because let's say that there's a particular product that does this. That becomes proprietary chemistry. So it's not something that they have to divulge, right? So that's why there's so many compounds that we don't know about. They're proprietary chemistry. They're tricks of the product, right? So companies protect their proprietary property and do not have to disclose information about these chemicals. But currently we're playing catch up to identify and treat changing chemistry. Next slide. That's a picture of whack-a-mole. Honestly, as they come about, new ones take the place. It's a quick identification primer. And I highlighted, the ones that I've highlighted are the shorter chain compounds that are the most hard to treat, okay? So you can see that your PFBS, your PFBA, those are your butane-based compounds. Pretty hard to treat. Your PFPES is actually not that bad for adsorptive and ion exchange. Your PFPEA is. So in general, your carboxylic acids are harder to remove than your sulfonates. But this is a nice slide so you can see, it takes the alphabet soup out of it a little bit more. So that when you look at these things in the middle, the HX, so you can know that it's based on a 6-chain chemistry. Next slide. Structure and behavior properties are the most common PFAS found in the environment. I know you've talked a lot about structure, what it means, but also the structure kind of gives some tells into the behavior of the compound. So they typically have a carbon fluorine tail and a non-fluorinated head consisting of a polar functional group. The tail is hydrophobic and lipophobic, water and oil fearing, while the head groups are polar and hydrophilic, water loving. So why is this so important? Why is this dual thing so important to PFAS chemistry? Well, because the tail will kind of wave and repel everything off of it, while the head is stationary. So whether it attaches to fabric, whether it's embeds itself in a layer, and so that you keep the layers separate, it's a surfactant. So that's what it gives it the property for firefighting film forming foam, excuse me, is because it forms a film layer so that you're not able to ignite fuel source, okay? It also, in the plating industry, it's also forming a film so that you're not gonna have the hex chrome come out of the backs, okay? So it's this protective layer. It's the same protective layer that you would treat your fabrics with so that it keeps the stains off of them. So the structure really kind of gives it its behavior properties. So length of the tail is also linked to the mobility in water. The longer the chain, the less mobile in water is a general rule of thumb. So your longer chain compounds will stay to the solids, soils, while the shorter chain compounds are the ones that are going to be at the head of the plume. So the shorter the chain, the further it's going to travel from the source of contamination. The replacement chemistry is geared towards shorter chains with branched functional groups, okay? So not only is it that they're making them branched, but they're connecting them in a way so that, like, let's say if you look at this particular thing right here, let's say you went into your third fluorine, you could put another carbon with maybe a hydrogen in there or some other functional group. And then what would happen is, under certain temperatures, that's the weakest point. And so you're going to break it off into even smaller particles, okay? So these are the kinds of things that we're seeing for the replacement chemistry. Again, just talking about this dual behavior and why it makes it such an incredible source for doing so many different things, okay? Next slide. Now we're going to talk about the current analytical tools for identification of PFAS. So LC-MS by MS, including 530 series of methods. So these methods are targeted analysis methods. So what does that mean? So the very low detection limits capable of seeing concentrations below 1 part per trillion. How do you do that? So what's actually happening? So an LC-MS by MS is actually 3 mass specs in a row. And so what you're doing is you're sorting, you're sorting, you're sorting. So you're getting down to a very specific structure. So any change in that structure will change whether or not you're being able to see that compound, because it's looking for very small. So when you do mass spec chemistry, it's kind of like you're breaking things apart, and then the little pieces that it breaks up into is what you're looking for. So those are the signifiers that tell you what that compound is, okay? So there is a trade-off. You can see down very, very low, but you're only seeing a very small portion of the total PFAS that could be present, okay? So a small change in the chemical structure would make the compound invisible, because the current methods being employed commercially are so targeted and selective. So of the over 6,000 compounds that fit the current definition of PFAS, there are approximately 40 compounds with commercially available standards. So out of all that stuff, these are the only ones that we can see by our commercially available LC-MS by MS analytical methods. So to illustrate this, just to show you how tricky it is. So let's say that you have a perfluorinated compound over on your right, okay? So this is where all of the carbons have been fully replaced with fluorine, okay? So it's a it's a perfluorinated compound. Okay, so let's say that this structure is changed and it's exactly the same, except for one of those fluorines, it's a hydrogen. That compound is invisible to the analytical method currently. So you can understand how we're only seeing a very small portion of it with the analytical methods that we have available currently. Okay, so if anybody has any questions about that, let me know in the question section. So next slide. So where were they found? Obviously the DoD sites, municipalities in the drinking water and wastewater, landfills, airports, Superfund sites. That's the one that scares people the most. And I'll get into that in a minute. End user industrial clients, plating facilities, biosolids, which has been one of the fastest growing markets in the last couple of years, and then obviously fire department training centers as well. Why are Superfund sites so troublesome to people? When you're treating for PFAS, you can use a lot of the same technologies that you do for like your volatiles and your semi-volatiles, right? So let's say that you had a site that you were treating for TCE or PCE. Well, you really didn't know that you had PFAS in your project, right? So you're testing, you've only got like a 7 or 8 minute empty bed contact time. You could have had the PFAS leave the site with treated water. Okay, so that's why it's kind of, it was invisible to us. We didn't know it was there, but it was still there. So where did it go, right? So that's what some people are fearful of discovering later on. Okay, so next slide. How did we get here? All right. So UCMR3 was really the turning point where public water supplies identified communities impacted by PFOA and PFOS. And, this is why previously they were phasing out the C8 compounds. There was, the C8 study that came out, and this is why we phased it out of production. In UCMR3, they had PFOA, PFOS, and a few other compounds of interest. And in the beginning of the UCMR3, laboratories were only able to see to about 200 parts per trillion. So then comes along 2015, 2016, and the analytical methods take a much lower reporting limit, okay? So at the time of UCMR3 testing, the reporting limits was 200 parts per trillion for a number of laboratories. By 2016, the industry standard dropped to 2 to 5 parts per trillion, and additional compounds were added to PFAS testing methods, okay? And then in 2017, the public awareness in New York, New Hampshire, Vermont, and North Carolina, followed by Michigan in 2017. Up to this point, New Hampshire was probably the leader in PFAS testing and monitoring, and that's because they had two things happen simultaneously. The UCMR3 uncovered an industrial user that was contributing PFAS to the environment, and at the same time, there was a military site that was impacting drinking water. So New Hampshire had it from both sides. They had it from the industrial, and then they had it from a military site. So they wound up doing a lot of testing. They did all kinds of programs that other states adopted. And so in 2017, Michigan really didn't want anything to happen that was going to be another Flint, Michigan. And it was actually called Flintification. So they decided to take a really aggressive approach to PFAS. And so they have some of the strictest standards in the country right now. And Wisconsin, a nearby state, has adopted that and has even gone further with creating their own analytical list, which is the most extensive in the US right now. Next slide. So this is the basis of everything that we do for water treatment at Clean Harbors. It's the skid approach. So we're going to separate the contaminants from the water by mechanical filtration, adsorption, and ion exchange. Contaminants are concentrated from large volumes of water onto relatively small quantities of media. And so the contaminants are isolated onto that media. And then at that time, it becomes the choice of the client what they want to do with their spent media. At Clean Harbors, we've taken a really conservative approach. We're only taking it to our closed loop landfills or to our max compliant incineration facilities. So our closed loop landfills are hazardous landfills that are treating leachate. So it does not go off site and to go into any other bodies of water. And then our max compliant incinerators are the highest compliance incineration standard certification that you can get. Okay, so if a client decides that they wants a third option, and we're not third partying that material, so we're not going to be signing the bill of lading. Doesn't mean that you can't do what you want to do with it, but we have decided to take a very conservative approach for PFAS material. Next slide. Project lifecycle stages is identifying, characterizing the water with applicable test methods, pilot study if we have time, defining the project objectives, which actually becomes the most important step, and we'll get into that pretty soon. Selecting the best fit approach, economically, size-wise, time-wise, and client and regional entities deciding upon that, right? Choosing the equipment and the media, O&M and servicing of the system, and then the final deposition, whether that be landfill, reactivation, or incineration, okay? Next slide. Identification. So what are the important things when you're talking about identifying PFAS? Your analytical lab choice is really important because their experience with doing this type of analysis is varied. Have they been doing it for a couple of years? Is it something they've been doing for a long time? For example, multiple runs might be required to meet low detection levels if there are high concentrations for other PFAS compounds. So 6.2 FTS can dwarf PFOS in plating facilities. So it may need to be run twice to get that type of specified analysis, right? And then choosing the appropriate compound list, state-specific lists like Wisconsin, Michigan, the DOD list. Not all labs, if they're looking for Gen X, have those standards. We like to use the DOD list, 24 compounds, and the laboratories that we use are accredited for DOD, only because in the event that a customer would like to have their analysis looked at by this particular group, they have to be accredited by it, right? So that's one that we use. We find that it is, until there's new analytical methods by the EPA that are put out, this is one that has criteria that needs to be met by all laboratories. So it's more of a standardized method to compare the analytical from one laboratory to another, right? Currently modified 537 is not standardized across laboratories. New EPA methods will create standardization between the laboratories. The question now is, so when do you make the switch? So let's say I've been doing all of my analysis by DOD accreditation, and the new EPA method is going to come out. When do I switch? And a lot of times what people will wind up doing is staying with the method that they had originally done, or do them both so that you get to a period where you can compare the two methods to make sure there's not a lot of difference in what you're seeing. Okay, again, that's going to cost more money if somebody is using two separate analyses at the same time. Okay. So test for other analytes that might interfere with the absorption and ion exchange. DOC, iron, phosphate, PDS, VOCs, SVOCs. And then what other analytical methods? I believe someone else was talking about the top assay. It's a total oxidizer precursor assay analytical method. It helps to identify the dark matter. It's good for initial water characterization because what it does is it gently oxidizes and heats it, so it breaks it down to its base component. So when we show that other slide about the polyfluorinated, it'll break it down to a perfluorinated, so we won't be able to tell you how much is in there or exactly what the compound was. It just gives you a better idea of the mass loading of PFAS that your system will need to treat. Okay. Next slide. Unidentified PFAS compounds can be considered dark matter. They consume media and shorten the expectancy lifetime of that system. So a double-edged sword. Low detection limits means very selective identification. So you want to have an ability to at least have a gauge of what else could be in there competing for your absorption and ion exchange. If we talked about top assay, it's not qualitative, but helps with general quantification. Next slide. Here we go. So developing the less targeted analytical methods, we talked about the top assay. And then there's also the EPA method 50/50 followed by method 90/56 for fluorine analysis. This is more of that total organofluorine. Reporting limits are high in the ppm range and identification is very broad. This method is good for highly concentrated waste streams to get an understanding of the total fluorine count. However, if your discharge criteria is in the parts per trillion range, low ppb, this is not going to be the method that's going to tell you what you have in your system. Okay. This is one that I hope gets developed more. Total fluorine by IR. The reporting limits are still in the ppm range. It gives you information on all the carbon to fluorine bonds present. So it's similar to the old ppH by IR method. If we have any old lab people in the group, it was a great method that's no longer used. It would just be an indicator method. Okay. Time of flight, LCMS. It's very promising, but currently very time consuming and labor intensive. This is where you're actually identifying tentatively identified compounds, and then you can create a library of unknowns. So this is the only way that you'd be able to identify non-targeted low concentrations of PFAS analysis. It's not widely commercially available. I think that there's one lab in Australia that's commercially doing this. You'll find it in universities and possibly, actually, Battelle, I think, just purchased one as well. So, all right, next slide. We're talking about examples of C8. You can see how the structure changes, right? So now if you have any small changes, even in C8, you would not be able to identify them, okay? So you can see how just changing the structure, it would still be a C8 compound, but you wouldn't be able to see it, okay? If you have questions about this, I'd be happy to talk about it. All right, next slide. Pilot study, you know, if you have a treatment project, pilot studies are fantastic because PFAS analysis and PFAS treatment is not well represented by isotherm. So I know you guys are probably thinking, oh yeah, can you just run an isotherm and tell me how long my carbon's gonna last? Because I've got, 40 parts per trillion of PFOA and 90 parts of PFOS. Well, it doesn't work that way because you don't find PFOA and PFOS alone, okay? You're gonna find it in a broad mixture. It's been described by a gentleman in Wisconsin as a dog's breakfast, meaning that there's gonna be a whole bunch of different PFAS compounds in there competing for absorption and ion exchange sites. So if you did an isocalc, what you're talking about is those numbers are generated by spiking a known standard into BI water or some reference water and then doing a calculation on the usage rate. It really bears no valuable information in a real world application, okay? Because you're not going to find it that way, and it won't give you a full picture of what to expect. That's why pilot studies are one way that you're able to do that. Now, even if you had gotten a grab sample and done like a rapid small scale column test, you're not going to see fluctuation in system. So for industrial applications, it's really not a good indicator either, because the changing from batches and processes will create different water. So again, that's why a pilot study is wonderful. If I don't have time for a pilot study, then I normally put in a pretty robust system and make sure that the analytical is done frequently so that we can get a good understanding of the usage rate for the system. So next slide. This is the most important step right now, defining project objectives. It requires communication of limits to be achieved. What is non-detect? Is it 2 ppt? Is it less than 2 ppt? What is the compound list? What is the discharge criteria? Are there media requirements? Is BAC the only acceptable technology for a municipality? Discharge permits. Is there going to be a pH spike? Is that going to be an issue for your discharge criteria? Space constraints. Sizing for 10 to 12 minute empty bed contact time means bigger vessels. So good communication about where you're going to put this, where it's going to fit, where you're going to discharge to, who's going to be accepting the discharge criteria. It's not, I think the next slide is going to be a good example of it. So let's go to the next slide. Here we go. So here's an example of projects with varied discharge criteria. So these are projects that we have across the US, and you can see that, it goes from low GPM all the way up to 400 GPM. Initial influent concentration from low ppb to, yes, you heard it, ppm. And then the project industrial type. So if it's an industrial wastewater, an AFFF release, construction dewatering, AFFF remediation, industrial wastewater. And so where are they being discharged to? So a lot of times it's the POTW. So you can see that, right? POTW is the entity that's going to make the decision of where your discharge, of what your discharge system has to meet. It is rarely the national guidelines of 70 parts per trillion, okay? Because they're accepting it into their facility and they are making a decision about what they will accept. So a lot of times our systems have to be less than 20 ppt combined. What list are they using for it to be combined into? We have non-detect requirements. So you can understand this can get pretty expensive. So understanding what the discharge criteria is will impact the structure of the treatment system you have, okay? Next slide. Selecting the best fit approach, balancing the cost and performance. Depending upon concentration and flow, there will be a best fit solution For example, very low flow and high concentration may be best for straight incineration for some clients. Very high concentration and high flow may be best for a resin application, smaller vessels and higher capacity for media. So moderate concentrations and medium flow is where other considerations will sway the approach. That makes the best sense for the project. Remote locations may dictate remote monitoring and high capacity media in a Conex box. If you have, let's say that you have lower concentrations and your discharge criteria is not really that stringent, GAC might be straight GAC might be the solution for you, okay? So, go to the next one. The current options for treatment, granular activated carbon is the most widely accepted treatment option for PFOA and PFOS. Shorter chain PFAS compounds dictate very short exchange cycles. They still will remove shorter chain compounds. It's just how long it takes for them to break through, okay? Different resins are good options for longer and shorter chain compounds. I like to use resin as a polisher after my GAC for a lot of our projects because they're not, you might also have some VOCs, SVOCs that need to be removed. And resin doesn't remove the VOCs and SVOCs. It's very specific to PFAS compounds, okay? Not only that, but you want to protect your resin. So you may need to do some pre-treatment so you don't foul the resin and foul very expensive media, okay? So oxidation and other destructive technologies have shown effectiveness of breaking down longer chained compounds. Our hesitation is that with complex influent water, if you haven't done an extensive study and you're doing destructive technology, your influent changes and you don't have a change in whatever it is that you're using for destruction. If you partially destroy a long chain PFAS compound and make it into a shorter chain PFAS compound, that actually makes it harder for the removal process. So the only destructive technology that we're employing is in our MAC compliant incineration facilities, where we have the temperatures and the control mechanisms, where we already have approval for doing the gases, greenhouse gases, right? And so remember when I talked about if you take a part off of a compound, you're creating a greenhouse gas, right? A refrigerant. And then there's also incineration of water. We have some clients that is what they want. They want the certificate of destruction. Additives effective for reducing PFAS and highly concentrated waste streams. We're coming out with a new product line later this year, and we're under piloting study right now, where we're doing a PFAS enhancement removal system, where we're going to be testing it on 1,000 parts per million concentration of PFAS. So that's something that we're going to be talking about later on this year. Reverse osmosis, fantastic, love it. Very effective with PFAS compounds, but the reject stream can be substantial. And for us, keeping skilled RO operators on staff, they're in very high demand. So it's not something that we employ for PFAS. We do use RO for other applications. But let's say that you had a 100 GPM system and your efficiency was 90%. Well, that still means that you have a 10 GPM more highly concentrated waste stream to deal with, okay? So, next slide. Using the equipment, size may become an issue of how much space that you have. For a lot of PFAS applications, we have customers that want to rent them and then it's kind of like lease to own, so that they make sure that the treatment plan that they started out with is one that they want to continue with. Do they want to go from carbon to resin? Did they want to try another absorbent media? So choosing the equipment is a step that's important, knowing how much space you have, and what your capital costs will be, right? The next slide. O&M and service. With PFAS projects, analytical is an important part of the operation and maintenance program. So proper sampling, monitoring for breakthrough, and performance confirmation. So all three of those things are important for the analytical. So vessel swapping or on-site service, and then documentation of variables in the system. Changes in flow, changes in pH, changes in pressure drop. They assist in optimizing the system to make sure that you're getting the best out of it so that it's doing the most, and monitoring solids as well. So, next slide. Final deposition of media. So there's currently 3 options for media at the end of its life cycle. Landfill. Many non-hazardous landfills are not accepting PFAS material. Clean Harbors is accepting this material into our closed loop landfills. Reactivation. So we are not third partying PFAS material to reactivation facilities at this time. But if that's a choice that you make, just make sure that the temperature is adequate to destroy the carbon to fluorine bond. And then incineration. So not all incineration is equal. Investigate the control measures and the permitting that's offered by your facility of choice. Okay. So next slide. Where we have the incineration capabilities. Right now it's El Dorado, Aragonite, and Sarnia. So those are the ones that are accepting PFAS right now, and those are some of our other facilities. So next slide. Someone always asks what the MACT incineration process. You guys you'll get a copy of this as well. This gives you the incineration and emission control steps, temperatures of the kilns and the secondary combustion chamber. Goes through a spray dryer, baghouse 1, saturator, baghouse 2, denox, and stack. So there's a lot that goes into MACT incineration process. So again, permitting and control measures are, especially with the interim guidance for the EPA for PFAS disposal is stressing. It's saying, these are the things that are going to be important for evaluation. They didn't give any definitive answers on what the best technology was, but they did say that, investigate the control measures and then also investigate the level of permitting and testing that facilities need to do. So, okay. Yep. Current CH projects. So what are we doing? So we have full-scale current projects across the country, that are in the influence coming in the parts per trillion, for the ppm range, and then we're consistently achieving non-detect levels. So depending upon the compound, that's in the 2 to 5 part per trillion range. Piloting systems that evaluate difficult to treat and identify the best pretreatment and associated PFAS treatment. Every application is different, and many times the pretreatment requires more attention than the actual PFAS removal. This is really true. Difficult influent water. A lot of times the pretreatment steps that we're doing, the absorptive medias, are removing the PFAS, but are also removing the other compounds that are going to interfere with the other medias downstream. And not all medias work for every application. They're different. So sometimes one type of carbon will be best for an application, or sometimes it's another, or maybe it's a resin that would be better because of other things that are in the water. It really, really depends. And if there's anybody out there that's done method development, I feel like choosing a media is similar to choosing an analytical column. Not everyone works for every analysis, and there are special ones that will work best for the mixture of compounds that you're trying to remove, right? Okay, next slide. So this slide right here really goes to talk about industrial wastewater, how it can change, and how good communication with the industrial client, with regulators, with the laboratory is huge, okay? If you look over on the left-hand side, this is a system that's treating 120 gallons per minute, okay? And this customer wants to make sure that their discharge is lower than what discharge criteria is for the wastewater treatment plant, okay? So on the left-hand side, you can see for a number of months, we're in this stage where the highest concentration that we saw was 70,000 parts per trillion for 6.2 FTS, okay? And there were, you know, smaller amounts of other compounds there, but obviously 6.2 FTS was the driver, okay? So what happened in February 2019? Well, they made a change to one of the chemicals in their process. So we went from 70,000 parts per trillion to 700,000 parts per trillion, okay? Then you look at our control chart for the effluent, you see that spike and you're like, oh my God, you had a violation, or, you know, 6.2F2S made it out into the system, you know, even though it's like around 35 parts per trillion. Well, that's not actually what happened. What happened was that it wasn't good communication between the industrial client about what they were, you know, they didn't even know because they weren't told by the person that was supplying them the chemicals that this was going to happen, right? So they use it, and then there's this much water in the raw water. So the analytical lab runs the raw water, runs the effluent after it. So what happened? It blew out the instrument because it wasn't in the calibration range. So luckily, you know, you have 2 samples that are collected. So we're able to rerun the effluent sample, and it met within criteria, okay? So this is why good communication with your laboratory is important. They need to have experience, and then also continued communication so that the screening levels that they use are up to date, okay? This has actually been our test kitchen. This has been one that has taught us so much about the different medias and what they can do, their upper limits, and what compounds break through first, and how, right? So this treatment system is about 20 to 40 GPM, okay? And it was a pilot study, and they asked us to come up with a treatment train that would allow them to do this pilot study so we could evaluate which medias are best and what's the optimal time, you know, empty bed contact time for them, what compounds they do well. So this was it still is, it's actually still in use right now. It says December 2019, but they like it so much, they've kept it. It's gone on to treat other water, and it's actually been spec'd out for other projects across the US for treating AFFF impacted water. So this is treated for up to like 11 parts per million and having to get down to a discharge criteria of less than 20 PPT, PFOA, PFOS combined. So what did we learn from this? We learned that pretreatment absorptive medias do extremely well. We learned that if you don't use them, these other compounds will shorten the lifetime of the other medias downstream. Okay, and some really bizarre stuff about PFAS in general. We have run into situations where we believe that colloidal material has been impacted with AFFF and won't be removed unless we use a colloidal carbon, right? So things that you would not see PFAS doing in low concentrations, you scale it up and you see the true nature of these compounds and what they actually do. Okay, it's been pretty enlightening for us, and it's allowed us to develop blended medias and approaches for extremely high concentration, much higher than the 11 parts per million that we're doing with this project currently. So I know that sounds crazy, right? So, you know, we have drinking water places that are concerned with the low parts per trillion, okay? And here we are treating the parts per million, but that's actually a really good thing, because the more of this material that we treat, the less that it will impact downstream later on. So next slide. This is a case study for a petroleum processing client in the upper Midwest. This was in response to a fire, and then water was impacted by the AFFF. This was a quick response project. We were notified by the actual facility, and then also by an engineering firm. So we helped devise a treatment system for them that was devised and set up within a week, right? So once we had the PO, we had it set up within 3 to 4 days. One more day for analytical to prove that we met the discharge criteria. We trained the staff on site so that they could run the treatment system themselves, and just offered advice about monitoring between beds. This is a client that had decided that they wanted non-detect for all 24 compounds on the DOD list. So obviously they have some pretreatment, some carbon, and then a resin polisher lead lag. So they had very strict discharge criteria of their own making, not coming down from anybody else. This was their own decision. So, okay, next slide. Is that it? Okay. You know what? I missed one other slide, which I can send to the group. It was ambient concentrations in soil, and it had showed that across the country, you could look at what the ambient concentrations of PFOS were in soils, and it was really fascinating because it was in the high parts per trillion to low ppb range, right? And that's ambient concentrations. So, you know, when we talk about scale of compounds, you know, it's going to get a little crazy when we're requiring cleanup criteria if it's going to be lower than what the ambient concentrations in soils are. So we're in for a number of years of some really interesting stuff. But again, water treatment is something that can be done. So, you know, it's one of the ways that I feel like we have a good handle on what's actually happening. So that's it. I could talk more if I don't know how much time I have left.
You are doing great on time.
Yeah.
Aaliyah, we have time for questions. So Aaliyah, do you have any questions in the room?
We do not have any questions at this time.
All righty. Annie Lou, I had a couple come through.
Sure.
Oops, excuse me, the questions panel. They're all concerning discharging to POTWs. So the first
Okay.
one is given the unknowns of PFAS, are there any concerns with discharging to these entities?
Yeah, and I really, there's a couple of slides that are missing. So one thing that PFAS treatment does is it's non-selective removal, okay? So, we're talking about the different structures, and the beauty of the way that the medias work is that even if you changed a little bit in the structure, it's still going to remove that. So how do we know? Like, how do I know that it's actually doing it if we don't know that they're all there? Okay. You look at the influent water and then you look at the effluent water. Okay. So since it's non-selective, it's gonna take out everything that's similar in structure, and it's not going to care. So if you have a breakthrough of PFBA, which is actually of all the compounds that we know that we have analytical standards for, that's the hardest one, okay? So if there is the presence of these short chain compounds, then maybe there are some small short chain compounds that are breaking through. But if there are not, then what that tells me is that the media is doing what it needs to be doing and removing compounds non-selectively, okay? So it's kind of like non-selective removal with selective identification. And then the concentrations that we're looking to are so low, okay? The requirements are in the parts per trillion. And I can't stress that to you. That's really extremely low. You talk about what our VOCs, our SVOC concentrations are, and we're looking at it in the part per billion range. Okay, micrograms per liter, not nanograms per liter. So I hope that helps.
Great, thank you. Another question is what kind of pretreatment is needed prior to GACU and IX in your case studies?
So for anything that has any oily material, we use organoclay materials and zeolites. So we have blended mixtures of them, and depending upon what type of compounds are in there, that's the type of pretreatment that we use, right? So depending upon, I have to look at the analytical and then make a decision which one I think is going to work best, right? But what you're really trying to do is protect the carbon and the resins from fouling, okay? So really, it really depends upon what's in there. It could be a lot of iron, and then I try to make sure that things are done with pH so that I'm not dropping iron out onto a system. Or again, it could be oily material that I'm trying to protect.
Great. Have you performed an influent versus effluent total organofluorine analysis or even total fluorine analysis to determine the total PFAS removal efficiencies, excuse me?
We did do that. We did do it on some pilot studies early on. So we would do top assay on the influent and then the top assay on the effluent. And what we determined was that if you have removal, it's not going to, and that's why I'm so confident about it because we did it and there was nothing on the top assay for the effluent. But it showed a ton more on the influent when you're using the top assay, okay? Because really anything that you do to change the chemistry, like if you're hitting it, if you're oxidizing it, you are gonna break down your polyfluorinateds into your perfluorinateds, and those are the ones that are more likely to be on the analytical list.
Great,
Yes,
thank you.
so we have done it, and oh, the total organic fluorine, not useful for effluent, because we talked about earlier that the concentrations, the reporting limit is so high for total organic fluorine that it wouldn't tell you anything. Does that make sense to you? Because you're talking about high ppb, low ppm for the lowest that you can see using the total organic fluorine methods.
Okay, thank you. Another question, what is the approximate cost to treat PFAS water, cost per gallon?
Wonderful question. Wonderful question. It really depends upon the size of the system. The higher flow that you have and the lower concentration, the less cost per gallon. Okay. So if you have a really high flow rate and low concentration, you're talking in sub-cents per gallon. If you're talking mid part per billion, and you only have 200 GPM, you're talking in the 10 to 11 cents per gallon, and it fluctuates. Okay, so it's hard to determine. You got to know what's in the water, as opposed to what your discharge criteria is. So it's very varied. You want to send an email and get it some round number determinations, we could try to help you with that.
All right. One more question, back to the discharging to the POTWs. Which PFAS species are measured for the indicated discharge limits?
Oh, okay, so it really depends. So that's another thing when you talked about going back to the project objectives, right? So for the state of Wisconsin, we were discharging to surface water for one of our projects, and they wanted non-detect for everything on the DOD list of 24. So not saying that everybody's going to want that. It really depends, right? And then some will say, oh, okay, I just want this list, or some will say I only need this. And so that's why the agreement on project objectives is so important, because you got to know. So like, let's say that you've done your analytical and you're like, here you go, this is what you asked for. And they say, oh, no, that's not what I wanted. I wanted this. So that's why you got to really get that up front. And every community will probably be different. So communication with them is key.
Good point. All right. Well, thank you very much, Annie Lou. I think that wraps up your portion of today's session. And now we're going to go into that open discussion roundtable Q&A. And if all of our speakers could turn their webcams on if you're virtual, and if you're in the room, certainly if you guys want to gather around the podium and you can answer the questions as appropriate. We did have a couple questions come through that we didn't get to through our Q&A. So I'll give you guys just a second to turn on your webcams, and then I'll start asking questions. For those of you that are online, please go ahead and submit your questions if you still have them and we haven't answered them throughout the presentations today. All right, Aaliyah, do you see any questions in the room?
No, I don't believe we have any questions in the room right now.
All right, well, I'll go ahead and ask the questions that were submitted via the questions panel. Are we seeing any PFAS in precipitation? If so, how much? And really, does it matter at this point? So would somebody like to take that question?
I can.
Yeah.
Okay, let's try this.
Andrew, you'll probably have to go up front just for the sake of the echo on your computer with the microphones in the room.
Do you want this or do you want that?
Bear with us for just 1 second while we get set up here. Thank you for your patience.
I was thinking that's going to be easier to just sit that back there in the classroom and answer the question, but I guess it didn't work out. So yes, good question. And I think this speaks a little bit to the fact that PFAS are ubiquitous, Peter mentioned earlier. And this is because they do cycle the environment. So one of the release pathways, point source could be industrial air emissions, and even just sheer generation of dust. And then that goes into long distance atmospheric cycling. And anytime you have particles of anything in atmosphere, it goes without saying that precipitation will actually move that PFAS from that aerosols or adsorbed particles content in air, and then of course the rainwater will carry that PFAS. And I believe there have been studies relatively recently that looked at the concentration of PFAS in rainwater, even distant to any potential point source emissions. So yes, does it matter? I think it does, because that contributes to that ambient signature of PFAS throughout the environment. Anilu just mentioned the availability of background soil concentrations, and again, contributions could be there from long-term transport and deposition, and then rain washout to the ambient environment.
Anyone else want to chime in? All right. Our next question is, at municipal solid waste facilities, are there products other than the standard ones discussed that you would recommend operators look for to determine possible occupational exposure? And then the second part of the question is possibly alternative covers, such as those sprayed on waste piles or others. Who would like to take that one?
I'll take it. I'm standing off camera here. Absolutely. You would use everything in your arsenal, particularly at a landfill facility, it could be spray on cover. A lot of it is also minimizing the working face. That's a large portion of it, is instead of having a large expanding working face, where you're disposing trash, trying to minimize it to be as small as possible, so that way it would also minimize. So the whole idea is just to minimize any kind of risk that there may be to any of your employees or customers, and any method that could be used would be useful.
Thank you, Pete. Next question. How much PFAS does a waste material have to be subject to the RCRA waste determination process?
This is Scott. One of you guys may be able to answer better than I can, but I don't think there's a RCRA requirement at this point.
Yeah, I think maybe, are you thinking of the TRI requirements? Maybe, because there is an interesting thing. So if you're using these compounds, there's a big difference between like landfills and what they receive, and then what needs to be reported. Because I believe in the TRI, if it's less than 1%, they do not need to report. Okay, so that makes a big difference. So that puts us at a disadvantage because we could be receiving a lot of stuff that they don't have to talk about. Does that make any sense to you? So that's a little bit different. So that's an interesting point. So you probably want to look up TRI requirements for industrial clients.
Okay. The next question is there a replacement product to AFFF that isn't a PFAS?
I could speak to that if somebody that doesn't else have something to say. So so they went from C8 to C6 foams, right? And so then the next thing is the fluorine-free foams. So that is being developed. They're being used in Europe, I believe, and they're starting to come onto the market in the US. They have a lot of hydrocarbons rather than the fluorocarbons. So, but there's definitely information on that for fluorine-free foams, and what does that fluorine-free have to mean, right? So.
Right, great. All right, that's all of the questions I have so far. So just a reminder, we of course have a little bit of time left, but if you do have a question, please submit it in the questions panel. If not, we can provide you all back with a few minutes of your day and wrap up. But we'll give just a minute or two to let people submit if there are any questions. Any questions in the room, Aaliyah? Are we still okay there?
I think we are good here.
Okay. Well, I will go ahead. I'll give you my portion of the wrap up, and then I'll turn it over to Kima to finish us off today. I just want to thank everybody for your attendance today. I want to thank all of your speakers, our speakers today, for their time, their presentations, all of the valuable information provided, as well as some great information from these questions. There will be a quick poll at the end of the session. For those of you in person, it will be a handout, a hard copy. And those of you online, when you close out of GoToWebinar, you'll see a pop-up, and it's just a quick 4 questions. If you guys could provide us some feedback on what you thought today, we really, really would appreciate it. And if there's any topics you'd like us to potentially host a webinar in the future, please include those. And once again, thank you so much to all of our speakers, and thanks everybody for spending your day with us. With that, I'd like to turn it over to Kima.
Yeah, thank you everybody for coming and joining us virtually. And I also want to really thank the Trihydro Corporation team. They have been a very great backbone for me with my PFAS project, portion of my our solid waste management grant, especially Andrew Police. He has been very instrumental with all this and putting everything together and all of that. So I really appreciate all you've done to make this possible. And I want to thank all our speakers. You all did an amazing job. I know we're all learning and putting all of this together on PFAS, but you all did a great job. I want to thank everyone. Thank you and have a wonderful day.
Thank you.
Thanks, everybody.